Starting the stream. Do I have the transcoding options today? Let's see it. I do. Yes, welcome to stream number 403. Porting a Lua test run into Rust. Hope everybody's having a good day. I started this work yesterday, and this is what I have so far. This is the original C++ code for figuring out where our configuration file is, and here is our Rust equivalent. Yay! So, hey there, Rusubaka. So this is a tool that I run in my environment to mix the unit tests for my game with those for my game scripts. So, for example, this test is not C++ or Rust, it's actually Lua. To get Lua test to show up here in my Test Explorer UI, I made a runner called MoonUnit, which is also used to instrument tests, so to define tests and to down at the bottom here. I should actually just pick a shorter test. Here we go. To check expectations. So this hooks back into the runner. The runner was a C++ program with Lua embedded in it, and because I need more practice with Rust, I decided I would take this tool called MoonUnit and port it to Rust. So what essentially does is create a Lua interpreter, finds Lua scripts that have tests in them and runs them, and reports back their test results, passing or failing, and makes it look like Google tests so that the Test Explorer UI plugin that I use here can recognize the test results, actually find the tests and recognize the test results. And then I think that pretty much explains what I'm doing today. Hey there, Flyboy. It's going pretty well. How are you today? All right, so let me get my environment set up again. Sure, we'll enter this passphrase. Make sure that there's no changes. Working tree is clean. So yeah, if I were to run this on the command line, VS Code, MoonUnit, help, it has to report these 3 lines in order for testmate to be fooled into thinking that the test runner is for C++. Hold on a second. Love non-work programming. Yeah, me too. Took the day off? Great. That's what I'd like to do. Take the day off. All right, so running it without dash test help runs all of our unit tests and looks like Google tests, but it's not. It's actually running Lua tests. Hey there, Grumpy Jeff TV. Okay, what else do I need to get set up here? Oh, I need to show how this is running with the ported version. So that would be cargo. We need to do cargo build or cargo run dash bin MoonUnit, right? Oh, MoonUnit. Right, so right now it just locates the configuration file, and that's as far as I got yesterday. Looks like Google test, but it's snot. That's right. Crude teenage humor. I apologize for that. All right. So yeah, let's purposefully break one of these tests to demonstrate what happens. So that's what we should get. It used to be that the plugin was smart enough to take the line numbers and match them up, but I think the problem is the stack trace the names of the tests are too long, or the names of the paths to the tests are too long, and so it gets truncated here, and then, so the plugin can't say that it's that line, which is a bummer. How is the Rust testing different than Python? I'm trying to understand what you mean by Python. Do you mean like how do you run tests in Rust differently than you'd run them in Python? They just have different frameworks for doing it. For Rust, testing is built in. For as far as like the tests for Lua here that we're doing, there is no real difference. It's just that I'm going to program it in Rust instead of C++. Built in. Rust tests are built in, and I should probably get an example of that going. New window. I had this in the playground that I had. Open recent Rust. Now I need to remember which one of these had tests in it. It might have been Fibonacci. Yeah, here we go. So tests in Rust are pretty easy. You just mark a module as a test module, and you mark functions as tests, and then you can just run cargo test, and it runs your tests. So if I go to Rust cargo test, looks like I had a whole bunch of different modules that had tests in it, but the one that was Fibonacci was right here. So it's also there's also some built-in, well, not built-in, there's also some integration stuff with the plugin I use. I can just press this button and it runs the test, which is pretty cool. I could force it to fail by putting a different number in here, and now it fails. Pretty neat. Ahoy, Silmeth, how are you doing today? Grumpy Game Dev is here. That we have 2 grumpy viewers today. Nice. Really isn't that different than the .NET test stuff? Yeah, I guess so. C# has this kind of markup support. Yep. Hey there, Simsy. All right, so current task, not starting up the stream anymore. What am I doing? I am, let's do some refactoring. Well, hold on. Let me say porting Lua test runner from C++ to Rust. And then on the third line, I'll say refactoring how we find the configuration. Okay, because I wanted to do that before I got further into this. This one is done. We don't need, let me close some of these files. I don't need all these things open. With this one we need, and we need this one. Yeah, okay. So how we find the configuration file, it's kind of ugly right now. Thanks, Games. Was raining with 19 raiders. Ah! Thanks for the raid, thanks, Games. What were you working on today? Game stuff, I hope? Hi! Raid. Hey, JT. And thanks, Games. Thank you again. Thank you for the follows. Yeah, we're going to be porting some C++ to Rust today. And first I'm going to do some refactoring. This is a mess. A couple of things that I learned yesterday doing some homework, as in reviewing the Rust book and etc. I don't need to do ... and then +1 here if I do a inclusive upper bound. And that should still work. Let's run it from this other folder. Yeah, so no change. We still find our configuration file. It still searches the ancestor tree. Okay, so that's one thing that I mislearned. So if you have just something ... something, it's including the lower bound, excluding the upper bound. If you want to include the upper bound, you put an equal sign after the 2 dots. Interestingly, the font ligatures, when I do that, it raises up those 2 dots. See that? I have no idea why. Something to do with the font ligatures. Working on object pooling. It's not working. You're so defeated. Nah, it's okay. You'll get back into it next time and you'll be like, wow. Taking a break or going from one stream to the other really helped. Your internet is the worst at the start of the stream? I don't know why. Hello there, man. I hope your internet gets better. I guess it will because you're saying it's bad at the start. That means it'll only get good from here, right? Today came up with an unholy way for a Twitch bot to capture a custom reward and pass a command to console app without having to change the console app, but rerouting standard input when the bot starts it as a process. How is that unholy, though? Hacky, maybe? Is that what you're trying to say? Can't be unholy. It feels unholy, I see. All right. All right, so I wanted to clean this up because a viewer yesterday told me, in fact, we could probably say, I can probably remember who it was. Yeah, Comundo said to look at struct path ancestors as a more idiomatic way of walking the path here. So what we're doing is getting the path to where we're supposed to be looking for a configuration file, and then canonicalizing it, and then breaking it up into its components, and then collecting together segments or substrings of that. So like this output is showing, and forgive me for having the \backslash question \, but that's something that Microsoft decided to do for the canonical name of drive letters. So just ignore those slashes in front. It's d:\, .MoonUnit, d:\, projects MoonUnit, projects omniranium MoonUnit. So if this was the path, what it did was it broke it up into its segments and then tried looking from the root down to where the path was specified, right? So we're doing this in a loop by matching, starting with 2 segments all the way up to the complete path, and forming a vector out of that and adding .MoonUnit to the end, and then checking if that exists. If so, giving it to the runner, which is what gives us this line right there. And I'm finding my mouse cursor, that's fine. NT kernel path, yeah. Supports over max path characters, yes. Pro table flipper, hello. We're going to do some professional table flipping today. Try this with ancestors, maybe, yeah. Exactly. Man, you know it. Kim Mundy told us about ancestors. We're going to try that. I'm going to... Actually, what I want to do is do cargo doc, update my documentation. Probably also change the exists into is file. Yeah, probably. Don't think I'd ever have a directory called .MoonUnit, but you're probably right. Yeah, let's give you a point for that. Yes, we're only interested in files, indeed. Okay, now that I did done cargo doc, I can open up the local documentation here. And shortening this window some, let's look for ancestors. There we go. So we get an iterator. It doesn't actually say which direction we get, so I guess we'll just try it and see. I might have to reverse it then, right? So rather than doing components, we're going to be doing ancestors. And we're going to be, it's not going to be path segments. Well, let's see, let's just see what happens when we take this and enumerate it. So for, what to name this? Path in that, then that gives us an iterator, so I don't have to call iter on it. And then I'm going to, that's a path. Can I say that it is path plus MoonUnit? I wonder if I can say that, if add is supported. Bummer. Oh, wait a second. That's probably because of that, right? And I probably don't need that. Equals. Okay, add is not supported for path and string. Can I say that this is a dot into? Nope. Doesn't know how to add paths together. Guess we can't add paths. Plus consumes the path? I think that's okay, right? Does ancestors give it to me as a reference? Yeah, it's fine. But the problem is, I guess it doesn't know what we're turning it into. Let's say we're turning it into a path buff from that. Will that work? Nope. Oh, do I need to dereference it? Nope. We can't add paths and path buffs. Can I say path from? Nope. You need an own path to do plus? Okay then. To owned it is. Wow. Still having trouble. Can't add path buffs to path buffs. Obviously I don't know how to use path buff yet. You're the Nick program. Do I remember you? I think so. How are you doing? WP Nicking, formerly known as the Nick program. Why did you make a new account? Why don't you just change the name of your old account? Reference the right hand. Do we? No. We can't add... What if I reference both? Actually, that doesn't make sense. Okay, we'll just have to look this up. Because I don't like guessing. So I'm going to look up Rust add paths. How about concatenate paths? That's concatenating strings. Uh-oh. We're going to be hearing some noise. Well, the volume isn't too high. Guys, let me know if it bothers you, and I'll have to mute. People are working on our bathroom again today. Oh, okay. The other thing I could do is just look up path and see what methods we have available. Yeah, still working on it. Yep. They installed the bathtub yesterday, and today it's, I think it's the toilet. I just assumed that we could add them together, but apparently we can do that. But maybe there's a way to figure... What's push? Oh, there we go. Extend self with path. The path absolutely replaces the current path? Well, that is what we want, though, right? Not only noisy, but smelly? No, we got a good plumber. It's not smelly at all. As long as you properly cap the sewer pipe, then no problemo. Oh, we don't need to see that window. So I guess I'll just do it this way. So that's what I had before, right? Right, I can't see the diff in this window. If I just say that, and then possible configuration file, push that. That works. Yeah, it doesn't implement add trait. Yeah, wouldn't that be cool if it did? But we can do it this way. It's not as good. Let's try it out. I'm thinking it's going to be doing it in the wrong order, though. Yeah, so I need to reverse it, looks like. So, question is, can iterators be reversed? I don't know enough of this, so let's see. Is there a reverse for iterators? How about just iterator? I'm guessing no. How come there's no hit on iterator? That was weird. You would think that I would get a... Anyway. But, oh, if they were strings, I could do that. But pathbuff doesn't, and path doesn't. Yeah, why am I in async standard? Iterator. You would think that my cargo doc would have all of my documentation, not just async standard stuff. I don't understand. Well, let's just open up another documentation thing for just Rust docs. Whoa, what happened here? That was weird. I had to refresh to get it to work. There we go. This is what I was expecting to see. Whoa, what the heck's going on? Huh. The CSS didn't load or something. Can I reverse an iterator? Rev? Oh, there we go. It only works on double-ended iterators. I bet this won't work then, right? Rev. Oh, maybe it does work. Nope. It's going to complain. It's not a double-ended iterator. So I guess what we got to do is collect it and then iterate it. Can I do that in one line? Collect. And then iter. Then reverse. Actually, let's see. What do I get when I collect the ancestors? What type is that? It's unknown because I haven't said what it is. If I collect it into a vector of paths, did I do this wrong? It needs to be a reference, right? There we go. Yep, collecting it, that's what I'm doing, collecting it into a vector, and then I'm hoping to be able to reverse it. Yeah, reverse and then iterate it, right? Is reverse mutated in place? It does. Okay, so then I would do that iter, right? Can't push into that because it's a double reference. This is the wrong type. I would just do that, right? Whoops. Nope. What's the error there? Oh, wait. Hold on. Okay, cool. I got the correct type. What's wrong with this one, though? It's not mutable. There we go. Don't need to specify the type of vector item explicitly. It should work. I guess. Well, I'll remove it in a second. It would be cool if it just implicitly knew what we were collecting into by what I'm doing, but it probably doesn't, right? Do I actually need to do that, or did I have that wrong? Yeah, it's not the correct type unless I do that. All right. Okay, fixed it. Can never dereference a non-copy type from a non-mutable reference, otherwise you would move the target object. Yeah, I'm going fast and loose right now. All right, can I get away with not having the type here at all? Yep, I think so. Nope, I can't. Can't infer the type. All right. So we have to tell it at least it's a vector. And like you're saying, I probably don't need to say what the type is, right? Yeah, okay, cool. So I just have to say it's a vector of something, figure this something out. Reference to path, right? This we had to do because we're actually getting a vector of path references. And we don't want to make we don't want to clone the reference. There's probably an easier way to say that, right? I'm guessing I would say something like standard path buff from. I can just say that and it would accept it. Maybe that looks better. Yeah, that works. I shall take your mana. Jesse Spy, how are you doing today? Also, hello, Turn Forever. And Liquid Plumber. Somebody called you if you meant when I said plumber. Yeah, we have a plumber over today. You put type in ancestors rather than the turbofish. I guess that's another way to do it. I like the turbo fish though. Yeah, so you're saying an alternative would be just to say this, right? And then remove the turbo fish. I don't like this syntax as much, but I acknowledge that it works just the same. Path to and without explicit path should work to. It didn't for some reason. I think it was because it was making a clone of the reference instead of a clone of the path. So when I just said path to owned, it fails to push because it thinks that this is a reference to a path, and not a path buffer. In other words, if path is a reference to a reference, then to own is going to end up making a new reference to path. I believe it's because this is a vector of references, and iter also always gives you a reference. So it's going to be a double reference at that point. So better just be explicit about the fact that we let's go back. Oh, I guess I can't go all the way back. Okay, fine. Better to just be explicit that we want a path buffer from path. There we go. Can I get rid of iter? Probably, because that's implied, right? Yeah, you're right. You're right again. Liquid Plumber is right. Let me give Man a point for pointing out that we could put the type on the ancestors rather than the turbofish. That is correct. Can never dereference a non-copy type from non-immutable reference because otherwise that would move the target object. Yes. Path to path buff. Okay, I didn't know about that one. Let's try out these alternatives. Path to... Oh, there we go. Perfect. That works too. That's even better. Let's give you a point for that, Silmeth. See, I just don't know that these methods exist because I haven't studied the entire list of methods available. What are we doing here? Oh, I'm holding down the wrong key. There. You do ancestors into iter reverse. Into iter. No, I couldn't reverse it. That's what we tried at the very beginning. I'll try it again. And oh, wait a minute. No, I didn't try that. I tried reversing the ancestors iterator. You're saying after collecting it, I can put it into an iterator and then reverse it rather than reversing and then iterating it, right? So you're saying I could do, instead of reversing, fighting my keyboard, into iterator, reverse. Yes, I think you're right. I can do that. And then I don't need to mutate this one because it got owned. Yep. Another point. Yeah, we couldn't reverse this iterator, which is an ancestors iterator. It's not a double-ended thing, but we can reverse the iterator we get from a vector. I'm guessing because the vector we can randomly access, so it's easy to reverse that iterator. Hey there, Draco. How are you doing today? Okay, I am still getting used to this keyboard, so you're lost? Okay, let's pick it apart one bit at a time. So we're given in our options. How do I go to that? How come the control click's not working for that? We're given in our options a path, relative or absolute path to a folder which contains or has a direct ancestor folder which contains, and that's the important part, a .MoonUnit file specifying a bunch of junk. Not important. It's just got our configuration and that's all we need to know for now, right? So options.path has the leaf node directory that we were going to want to start our search for configuration files, and we search from there all the way up to the root directory, right? So we're going to take that, and because it might be a relative path, we're going to canonicalize it first. And then that could fail, so we unwrap that. And the canonical path now, it's in a path buff, right? This ancestors method turns that single path into an iterator of paths. It's going to give us the paths starting from where we are and going up. So it's going to give us d: projects on the arena, then it's going to give us d: projects, and then it's going to give me d: root directory, right? But if I want to search from the root directory down instead of from that directory that we started at up, we need to reverse that. Problem is this iterator we get from ancestors is not reversible. It doesn't implement the trait to be able to reverse it. So what we did is we collected it into a vector. Basically, we're stepping through at this point and kind of freezing the actual list. Because if you remember in Rust, it's lazy evaluation. So we don't actually have a list of all three paths after we call ancestors. We have an iterator that if we were to call next on it, will give us those three paths. So collect will actually step through that iterator and give us a vector with 3 elements in it, right? Now that it's in a vector, this is a vector, we can convert it into an iterator. That's what into iter does. It basically eats the ancestor vector and produces a vector into that, an iterator into that former vector. And then because that kind of iterator is reversible, we can reverse it so that we get this order. So if I took out the reverse, you'd see that instead of going from the root down, it's going to go from from the leaf up, right? So if my specification was to go from the leaf, did I hit save there? Yeah, if my specification is to go from the root down to the leaf, which is what it is, then we want to reverse it. And then now that we've reversed it, it's an iterator, so we can use it in a for loop. So every path here will be one step of that reversed iterator of ancestors. And we have to turn it into a path buff in order to modify it, because these paths are just immutable references to paths. So they're we can't change them. But to path buff takes that path and copies it into a buffer that we can then change by adding .MoonUnit. Hopefully that makes sense. All you can do is hello world. Yeah, this is what you'll be able to do if you study and practice Rust for about a month. That's how far I am. I'm about a month and a week into it now. Ancestors is an iterator itself. Well, yeah, but it was an iterator, but we couldn't reverse it. Maybe you don't need to. No, I needed to collect it because I can show you again. If instead of collecting it, we just reversed it like that, I get an error saying that it is not reversible. The double-ended iterator trait is not satisfied. It's not implemented for path ancestors. So you can't reverse an iterator you get back from the ancestors call. So we have to collect it to get a vector which we then can reverse. This is really interesting to watch. What were we talking about? Only a month? Well, I had the leg up. I've been doing programming for 25 years, so I've had some programming experience. So if you've been a developer for one language for a really long time, it's easier to pick up a new language. Rust, I think, is a bit harder to pick up because there are things that are unique to Rust, like what we're bumping into occasionally with the borrow checker, and the fact that sometimes things are references and sometimes they're not, and sometimes you can get weird things like double references, and yeah, that's sort of unique to Rust, I think. Hold on a second. I need to drink some water, I think. Yeah, so what into iter does, whenever in Rust you see the word into, it means that you're transforming. So after this call, I can't use ancestors anymore. If if I said like let x equal ancestors, it's going to say, well, that you can't use ancestors anymore because you've already moved it. Right. Use of moved value ancestors. It was moved on line 43. It was moved right here. So whenever we do an into, we're taking ancestors and we're moving it somewhere else. Where are we moving it to? In this case, we're moving it into an iterator. So I think that's why they use the word into, because you can sing it like a sentence. You're saying we're taking ancestors and we're moving it into an iterator. That's how I like to think about it. It's taking you more than a month to read the book. Yeah, so once you get done with that book, I have a recommendation for you. I did this yesterday. Helped me out a ton. So, you go through this book, right? At your own pace. But let's say you get through the book and you're like, yeah, I understood pretty much all of that. The next thing I suggest you do is go one level up and then down into Rust by example. Rust by example is a really good companion to the Rust book because it'll go over all the same stuff again, but it does it with actual code examples. And I don't know why this big bar is in the way. What's up with that? Okay, there. Now it's gone. No, now it's back. What the heck? Did you reload this? Huh. Anyway, this Rust by example is predominantly code with short explanations. So it's a good companion to the book because the book is more words than examples. This is more example than words, and they cover a few things that that book didn't really cover, and that kind of help fill in some of the gaps. And I can't tell you any particular examples, but I would suggest you, yeah, it's a good thing to look into. And then in addition to those, I've also been looking at just the Rust docs. So you'll see me actually, as I was already on here. Just whenever you're not sure about what something is, like what you can do with an iterator, I looked up iterator and I saw, oh yeah, there's reverse, right? Reverse is it, but then it says it has to be a double-ended iterator. So you just learn things by looking at the reference guide. And then you just have to get used to how to read the left-hand side, right? So if you're looking at something like, I don't know, a unbounded sender, is that going to be here or is that going to be here? Yeah, so let's say you're looking at some asynchronous channels, right? And you're looking at this structure and you're like, how do I use that? What I've learned to do on the left-hand side is methods are things that are unique to that structure, but usually you use structures through what traits they implement. So this is the key one here, that an unbounded sender is a sink. A sink is the writer end of a channel. And also here you can see that, oh, if it implements sync and send, that means it's it's thread safe, and you can send it to another thread, right? And some of these other things will give you hints like that you can, like this sync extension, and there's an implementation of sync extensions for this type. So anything sync extension can do, we can use it with that unbounded sender. So we can do any of these things with it. Yeah, it's useful just to look into what you can do with certain objects and what traits they implement, and get used to what the traits are for. Like what is a channel, what's a sync, what's a stream, that kind of thing. What's a future? Never liked Rust by example that much, since most of the times you checked in the examples were too simple, didn't answer your questions. Yeah, but if you're just starting, that's what you want, is say simple examples. Silmuth, you're an advanced expert by now, so you're probably way beyond the what Rust by example can help you with. Yeah. So yeah, those books will get you started, but their usefulness will sort of degrade over time, and you'll probably want to find more advanced stuff. Anyway, can I clean this up anymore? I'd really like to do away with this variable and just put this in, but I don't know if it'll let me do that. Oh, maybe it will. And then I'd kind of just like to do this to it so we can see it in this format. There, I like that better. And then I can even use Can I do this? Can I just grab that and put it there? Neat. I think that that looks nicer, and we can kind of see what's going on. We get the canonical path, and we are looking at its ancestors. We collect it and put it into an iterator, and then we reverse it. Nice. Started the stream late. Was everyone talking about Rust 1.45? What were we talking about? I'm still on Rust 1.44. Should I be updating? Is there something cool in 45? Okay, can I clean this up at all? It'd really be cool if I could just say add .MoonUnit to the path, but I don't think we can. This is the best I can do, right? Or released an hour or two ago. Yeah, maybe not while I'm streaming. Nothing major. By the way, hello, DHG Hummin. How are you doing today? And Silent Z. And who else is new here today? Infini is new here today. Lumacode. Hello. I'm looking for your chat. I just can't see it. I'm sorry. Oh, there's a new message from you. Hi. And A squared. A squared is here. Woo, Rust. That's right. You can do a 4i and A through Z now. Oh, you couldn't do this before? 4i in A to Z. Couldn't do that? Oh yeah, I guess not. The one thing about Rust error messages that takes some getting used to is to understand sometimes what they mean. Here they're saying the trait-bound character standard iter step is not satisfied. That is the Rust secret language code word for you can't make a range out of characters, because in order for that to be possible, the type character or the type range of character would have to implement the trait step. This trait step here is what the implementation of the trait step is what allows you to use syntax like that. That's what it's trying to tell you. So I take it in Rust 1.45, what they did was they added the implementation of standard iterator step on range of characters, which makes sense. You should be able to do that, right? I assume that it would just pick all Unicode code points between those two characters. Am I right? So if I did from A to poop or something like that, it would still work. It would just maybe give you a strange... there would be a strange journey to get from one to the other. Poop. I'm assuming you could do that, right? Anyway. I have kids. Kids like bathroom humor. Throw that in there every once in a while. Alright. Can I clean up any... Oh, right. There was one of you, I think it was Silmeth. Could have been man. One of you experts was telling me instead of doing exists, I can do is file. Then it won't catch directories. Alright. Let me check this progress in. This is progress. So, refactor how we walk the path to find configuration files. So, number one, what we did was use, this is technically path ancestors, I'm guessing. Use path ancestors to walk the path. And now, the second thing would be, well, part of that is, since this walks from the... Oh, I'm being raided by Mr. Halsey with 22 more rustations. Welcome, Mr. Halsey. Jolchab, hello. How are you doing? All right, path ancestors walks from the given path up. We need to reverse this in order to get a traversal from the root directory down. All right, and the second thing we did was to use is file rather than exists in order to avoid thinking of directories as files by accident. There we go. Doing the responsible thing and making a git commit before I move on. From A to poop. That's right. You can do this in Rust 1.45 now. We learned that although you cannot traverse from A to poop in Rust 1.44, you can starting today. Don't know why you'd want to do that, but apparently you can. All right, what are we going to do next? By the way, welcome Raiders. What I'm doing today is I am converting a tool that I use to run Lua unit tests that allow me to do cool things like set up a test completely in Lua and make it integrated into VS Code by the nature of using an already existing plugin called C++ TestMate that can find test runners that look like one of these three kinds of frameworks. And since I'm familiar with Google Test, that's what I chose. I basically made my own test runner in C++ that looks like Google Test, but actually runs Lua tests instead of running C++ tests. And the TestMate is none the wiser. And it's really cool because we can see what all of our tests pass or fail graphically. I can show the log here and see exactly where the failure was, on which line of the script, which is down here. If this was perfect, it would highlight that in red, but I think because these path names are being truncated, it's not able to do that. But anyway, it's pretty close. And this tool already works. I use it for my game. This is the unit test for one of my game scripts. It's the can afford script. Can a player afford something from a shop dealer, right? And we set up, here are the different entities, the player, the food that they're trying to buy, the gold, and actually I think it's that the player has both food and gold. Right. Can they afford something for 20 gold, 25, 30? The test added food here just to make sure that we don't count food as gold or money or whatever. And we should say that they can afford it if it's 20 or 25 because they got 25 gold, but they can't afford something for 30. And yeah, anyway, that is how to make the test pass. So it's just really convenient to have this test runner. I can do it all inside of VS Code. Already was working in C++, but since I learned the Rust programming language about a month and a week ago, I decided, hey, let's do some more practicing with Rust. What better than to take a standalone tool like this test runner and port it to Rust? So that's what we've been doing. Sounds pretty complicated? Maybe. So it's a program that hosts the Lua programming language inside, the scripting language, which is, I have a YouTube video that talks about how to do that. And that in itself is one subject. So once you learn how to embed Lua in a program, there's not much more to it because all of the tool does is just uses Lua to run a bunch of Lua scripts until this function in Lua gets called, and that tells the runner, hey, this function is a test we can run. And then when the test runner decides to actually run the test, it takes the function that was given to this test hook and just calls it. And then if we get these callbacks, we use them to decide whether or not the test passed or failed. So like if expect true is given something that's false, it's a failure. If it's given something that's true, it's not a failure. And if you get through all of your expects without failing, then your test passes. So that's the nature of a test runner. That's basically all it does. The complicated part is hosting Lua, and that we can deal with separately. Figure out how to make a programming language work in software. It doesn't usually have that software. It's merging two programming languages together, and then I'm making it even more complicated today by changing one of the two programming languages. Yeah, so it's called hosting, usually when you take one programming language or framework and put it inside another. So we're taking the Lua programming language interpreter, or the compiler, you can call it, and actually putting it into a larger program. Yeah, so C++ and Rust don't intrinsically know how to run Lua, but if you take Lua and put it into a program compiled in Rust or C++, you can then do it. And Lua is really nice, a really nice choice because the API they provide is really friendly for doing that kind of thing. So I did this I was showing this yesterday, how we can do it in Rust, and I can show it again. We're using the mlua crate or library. So all you need to do is say that you depend on our Lua, and all the hard work has been done by everyone else. All we need to do is say Lua new, and we have a Lua interpreter. And then within a Lua context, we can load some Lua code and execute it. And if we get errors back, we get them here. I was playing around with this is defining a function in Lua called report. So once we know we've loaded and executed that, there should be a Lua function called report. So here we're getting it, and then we're calling it with some input, and then we're printing out its output. And this report is basically adding two numbers and returning a string that says what it is, and so that's what it prints out. So it's pretty neat in that we can take one language and stuff it inside another one through the use of a hosting environment. So that's what this Lua object we get in Rust is hosting the Lua interpreter, allowing us to both run Lua programs and then interact with it, like call into it, call back out, that kind of thing. What Lua we're using? We're using Lua 5.3, I think. Our Lua is baked in 5.3, and I think we were also doing, oh, that's right, MLua. With MLua, you get to say what version of Lua you're using, and I just said, hey, 5.3, just to be consistent. And there's not much difference between MLua and RLua. They're just, one's a fork of the other one. MLua maybe is a little bit easier to read because we don't have that context thing anymore. And I made a wrapper called with Lua that all it does is call the Lua stuff, and if there's an error, print out the error. But otherwise, it's just you load some Lua code in, and then you execute it. You can set the name. If you set a name for some Lua script, that name shows up in any stack traces. Crates.io is everything you need. Yeah. So that's another thing I learned when I was learning Rust, is that either crates.io or lib.rs, you can look up anything. So let's say, for example, you wanted to use PBKDF2, which is a popular password hashing algorithm. Someone's already done it for you, so you don't need to do it. Let's say you wanted to do SHA-256. Oops, bad gateway. I've had that happen a few times. But anyway, we have many different options for, this is a secure hashing algorithm, right? How about Raft? I use Raft algorithms. Someone's already implemented, so we don't have to do anything ourselves. Yeah, sometimes I get that bad gateway error, but I just refresh and it goes away. Had issues finding hashing algorithms? Really? I've been using the ones inside of Ring, which is a collection of things. It's got both hashing and crypto. It's too bad they don't have a really nice documentation on this page. I always have to like flip over to their home page to see it. But yeah, they got PKCS, they got PBKDF2, they've got Digest, which has the SHA-1, SHA-2 stuff. They got everything in there. They got HMAC. Used Ring in the end as well. Yeah, Ring is really nice. I've been using that. Things just work right out of the box. Let me say some hellos to people. Catching up on chat. Power Down Sis, hello. Rust compiler, of course. See, when you have the Rust compiler in your chat while you're learning Rust, can't get any better than that. Emil Gardis, hello. How are you doing? Yeah, I kind of like lib.rs better than crates.io. I don't know why, but you get the same results. If I type Raft here, and then I type Raft here, I end up getting to the same place. It's just maybe looks a little bit different. Maybe it's just the style of, or the color scheme. I don't know. It's the same information. I guess there is some extra stuff on libs.rs we didn't get with crates.io. Crates.io is not listing the features, all right? This isn't listing features either, because this one doesn't have features. Anyway, this one feels better to me. Uses another algorithm for ranking. Use whatever you prefer, right? Sir Mordred, hello there. Feel free to lurk. Lurking is perfectly acceptable in my stream. 715209, how are you doing today? And Mr. Halsey, thank you again for the raid. I hope you had a great stream. Wizard Frag, hello. This changes everything. Yes, I know. Ecton Dev is here as well. Wow. All the Rust stations are here. Even Frosty. How are things doing? Frosty, doing well. I took a month off from advancing the game that I'm working on so that I can learn the Rust programming language. And if you want to know why, it's mostly because people here have been asking me to try it out. But I've had a great time and learning something new and something very useful, I think. Hey there, Red Sky One. Yeah, at this point, like, there is nothing like this in C++ that you can just go to one place and just find the implementation of almost anything, like Lua. Actually, if you just type Lua, it's like, I did this yesterday. Where is Lua in Rust? Oh, it's on all these places. Then all I had to do was say, list it there, and then we're using it that quickly. We don't have to worry about where we download it from, how do we build it, how do we use their API really, because how you get it is very nice in Rust. The cargo tool just looks at your configuration here, and you say you want that version. Okay, we're going to download that and build it for you. It's pretty awesome. How long have I been writing in it? About a month and a half, or a month and a week. So my first day learning Rust was June 9, and these were really fun days learning Rust. So what I did is in my YouTube, I made a special playlist for those 4 VODs. If you want to see me learning Rust from scratch, basically, there in my YouTube, just look for that learning Rust playlist. Not that I recommend that anyone watch like another 20 hours of me stumbling around, but if you really wanted to, there it is. Rust just distributes source code too. It actually does both source and binaries, right? There's a way to distribute binaries, but most people just end up doing source because it's so easy. The tools make it so easy to, like, everything is automatically built for you. I haven't once run into, not yet, a problem pulling down and building some library. The only thing that I've had a little bit of issue with is that it wasn't immediately obvious what the licensing terms are, but like anything in Rust, I just looked up what tool we can get to do that, and I found that there's this find licenses. Cargo licenses? Okay, now I can't remember what it was. I have to look at what's the name of the tool again? .cargo bin cargo license, and we can look and make sure that everything is licensed, that everything is friendly. There's no like closed source licenses or any restrictive licenses here, and if there was, like, let's say I didn't really like the BSD3 clause, I could say, well, let's look for alternatives to these two, maybe see what depends on those and reevaluate that, right? That's maybe the only thing that didn't come automatically with cargo that I thought was missing. I think cargo should just include this if we want to know, like, what licenses we're carrying along when we pull in our dependencies. Cargo Denial, Cargo Lich King are great. Yeah. But like everything in Rust, everything is like one Google search away from finding it, pretty much. CMake uses static linking too by default, but it sucks. Some C++ libraries force dynamic DLLs. When I make mine, I try to make it so that you can go either way when it's like super reusable. Do I have an example of that? I don't have it right now, but yeah, within your when you're using CMake with C++, you can have options where you can allow stuff to be dynamic or static link. It's just more work for the person who's making the CMake configuration. Yeah, it's too bad some developers don't have that flexibility in their libraries. Anyway, with Rust, we don't have to worry about that. All right. Let me get back to my work here. So what are we doing? I am working on porting this test runner, and right now all that the C++ version of this test runner does is print out where its configuration file is, right? Yeah. It says it's here. the next step would be, I don't know yet, but we don't need this anymore because this is ported to here. So I guess what we're going to do is look at what the C++ code does after that point, and then it lists or runs all unit tests. Okay. So we're going to have to be able to ask the runner, what are our test suites? That's probably a good first question to ask, right? If a filter is given, then we are doing what? Actually, I don't understand what this is doing. What is this doing? Oh. Selected tests here. Okay, so if we're given a filter, then we know exactly what test to run? Is that what this is saying? I guess so. I guess this is assuming that if we're given a filter, it's giving us exactly which tests to run. If there's no filter, then we just collect all of them from the runner. And then if we're not just listing the tests, then we're printing this, what do you call this? Prelude. And then we're going through all of our tests and either listing them or running them. Right, either listing or running. And if we are running it, then we're timing how long it takes to with this timer. Running the test to get whether or not it passed or whether it passed or failed. If it passed, we count it as a pass, print out a pass. Otherwise, we print its failure along with, what is this? Along with any error messages we got. And then at the end, we're accounting the amount of time that elapsed total, printing out how many tests passed and how many failed, I guess. All right, so a lot of stuff we need to do. So I guess the first step would be the runner needs to be able to tell us what the test suites are. So let's do that first. Get test suites, just a vector of strings. Okay, so then the Rust equivalent of that would be pub function. I guess we'll just try to make it idiomatic from the start. We would probably just want to make have it return an iterator, right? So get test suites. Self, borrow self to get what do we want to say here? Is it going to clone out of our internal list? That's what this ends up doing anyway. Just to start out simply. So then it outputs a standard iterator of string. We haven't done it yet. Oh, that's the trade object. So impl. Can I not do that? Oh, I have to say item equals. And this is because of that, right? Actually, I thought saying to do would make this not error. Semicolon after to do. Thank you. Nope, that didn't help. Yeah, this is supposed to say back off, I'm not done yet. I'm thinking this is correct so far. All right, how would I do this? Let's just assume that I have stored here the vector. So just like in the C++ test suite names is a vector of strings, right? And then that means in new I have to make one. Standard vec new. Can I just say self.testSuiteNames iter? Well, clone into? Oh, you have to give it a target. Ew. Can I just say clone into iter? There we go. Did it. To do returns never, so it shouldn't complain. But yeah, but it does, which is weird. Yeah, I think I'm just gonna take the cheap way out and clone it for now. So it gets its own owned strings for now. Well, maybe we'll try to optimize this later so that it doesn't, so we can avoid the clone. Clone you want to avoid once you're good enough at Rust, but if you're not good at Rust, it actually gets you further to do extra clones because then you don't have to worry about running afoul of the borrow checker of lifetimes. Let me start with clone, get it to work, then I'll try to not use clone. How about that? Like if I did it right, I should be able to just iterate in place the test suite names, but I don't want to stress my brain too much right now. I mean, the C++ does the same thing, right? When we're making a new vector and pushing back that, we're ending up cloning the vector anyway. This internally was collected from this, which is a hash map from string to test suite, which has a hash map from string to test, and each tester remembers the file name, the path, and which line number was on. Okay, we ultimately need that, right? So what if I just do that now? So within here we would have struct test, and like we have here, we have file is a string, file path is a string, and line number 32. Well, size. Let's do use size. Line number. Okay, the test suite. Oh, I had that backwards. It's the C++ in me, wanting to put the type first, not second. Okay, struct test suite. It has a this tests, right? Technically, I don't even need a struct. I could use a type alias, I guess. But let's do this. Let's have it mirror the C++ code to start with. So this would be a standard collections hash map from string to test. And then test suites. Okay, this is a alias, so that would be type test suites equals standard collections hash map string to test suite. Cloning when pushing back, when? In the C++, where was I for that? It was get test names, right? Test suite names. Yeah. So test suite names is a vector of strings, right? So pushback is always going to construct a new string in C++. So this is implicitly going to clone. You can see it in two ways. One is that we know we're going to be changing the vector by adding something, but the input was a constant reference. We can't do that without cloning in C++. Also, when we see mplace back, that means we're constructing something in place. So this intrinsically clones the strings. In order to like not clone these strings, I would have to do like what we would do in Rust, where we have a reference to another string somewhere else, or maybe the whole vector would be a reference. So I didn't do that in the original C++, and that's kind of why I can, just for now, since we're just porting it as is, I'm going to do the same kind of thing in Rust. So that's literally the Rust equivalent of this, only I am doing one step towards a better life here by returning an iterator rather than returning a vector that would then need to be turned into an iterator. You can at least use hashmap. I'm warming up to that idea. The fact that we're making aliases means we're not going to be using hash map much. Right now, I'm forcing myself not to use just to get sort of memorized that I know what module hash map comes from. It's just muscle memory memorization kind of, you know. All right, so that's how we get the test suites. What do we actually do here? This is if the filter is empty. Okay, I'm not going to report this as is. I actually want to just test. I want to write a test. I really should write a test, but no, I'm not going to do it. I'm just going to, for now, list out all test suites. And this is temporary, so we would do for test suite in runner.get test suites. Say test suite. Test suite. Okay, so this is not going to print anything out right now, right? We got to make it work. And here's where we have to load the configuration file. We're going to need to execute a whole bunch of Lua scripts. We're going to have a hook to handle when the MoonUnit test is called, so that is adding a test suite. So this is going to take a while. Do I have... Okay, I don't have the current task set up right. I'm going to need to take a break within the next 24 minutes too. All right. Writing code to enumerate test suites. I think configure was supposed to do that here. Yeah, so really we're implementing configure because it ends up calling load test suite, which is what we want. So I think that's what I'm going to port next, is the configure here, rather than just printing it out. So this is all C++ we need to port. All right. This means if we couldn't open it for reading, return. So that the equivalent of that would be to get a configuration file and exit early if we couldn't open it, right? And that's standard FS open, I think. I thought it was open. Is it file open? File open. Configuration file. So we're shadowing it. And then dot... how do we have it return early if there's an error? It would be like... when I want to do an... See, this is where I don't yet have an intuition for how to do this. What is impl in C++? It's not intrinsically part of the language. It's just a pattern that I use called the pimple, pointer implementation pattern. If let an early return. But if I do an if let and I destructure it to be error, does that go out of scope after the if? It does, doesn't it? So I don't want to do that. I want to try to open the configuration file. If it's an error, return. Otherwise, I want the configuration file to be the file. Match? I guess, yeah. Well, I guess when in doubt, I should just start with match, right? So just do this, right? Okay. File, and then error. Actually, it doesn't matter what the error is. Then return, right? there's got to be something easier than this. What is this telling me here? Unneeded? Wait. Why is this unneeded? I want an early return. Is this not gonna... What's it trying to tell me here? It's a hint that I maybe... It's not understanding what I want. I can just say return? Okay. Okay, returning from a match, I'm just return from the function. Interesting that could just say return, though. Is that what I want? Okay, or? See, this is where I struggle, where I'm kind of weak still. I don't know how to... my weak points in Rust are... I don't have the helper functions committed, like and, okay, or else, that kind of thing. So, I want to look up what... result, I guess. Okay, you're saying I should use okay or. Is that... What is okay? I don't even see that in the list. That's an option, not a result. Yeah, I think we want to look... I want to find which one of these is correct. Is it or else? I think it's we want or else, right? Okay, yeah. So that would be this or else return, right? It doesn't like... Oh, that's a problem, isn't it? We need to give it a closure, and I can't early return out of a closure like that. Shoot. Ah! Ah! Maybe it's unwrap or? That would give me a default. How about or else? Again, that's an operation. Bummer. Yeah, we don't want to panic. We just want to ignore it. Like the original C++ would just ignore the configuration file if we couldn't open it. I guess I'll just leave this the way it is for now. Yeah, just leave that for now. Okay, and all of this is just to read it into a string. So I can just say let configuration equal configuration file dot wait, what? What can I do with the file? There's from file. Oh, that's to convert from standard I/O. What's read let me do? Read to string. So I have to make the string first and then call read to string? Okay. Let configuration equals string new. And then configuration file dot... How come it's not helping me here? I should be able to say read to string, right? Oh, probably because this is not mute. Read to string requires a mutable self. Yeah, why is this not working for me? Oh, I need to use the thing. I need to use a standard file. I need to use this one, right? To get that trait. Now it'll work. No? Hold on, what am I missing here? It told me where read was. It's available for boxed arc and RC. Oh, standard IO read. Okay, got it. Yeah, I know I could do read to string and not have to worry about the open, but I'm trying to port it exactly. So this also has if it can't open, so it has to do the same thing. If let error equal that return. Redundant pattern matching. Oh, I can just use if error. Okay. If that is error. There we go. Could do a toConfig function that reads from a file into a config struct, then do file open on wrapper default to parse the file or get the default file if not found. Okay, right now I'm just interested in importing this exactly because it's sort of an exercise. I want to know how to most closely make this into Rust, and then after I do that, then I'll probably want to refactor to do stuff like that. I think. Does that make sense? Hey there, oh Lord Jonil. Are we going to refactor for result? Probably, but not right now. I just want to get a straight port of this and then refactor it. Although I am taking some opportunities to improve it, like the fact that we're returning an iterator and not a vector of strings like in the original. So maybe if something's really cheap and easy and doesn't change the semantics too much, I'll do it. Compiler is super smart there. It's pretty smart sometimes. Your method can return option use. Yeah, if it returned an option, I could do that. But right now, the original function didn't. So I wanted to keep it like that. This original function didn't return anything. It was void. So it's just silently returning. So that's kind of like what I want to do. Just as an exercise, right? We're not trying to make the code right. If anything, there's two things going on here. My order of operations normally is to first make it work, then make it right, then make it fast. But the other thing is I want to use this as an exercise to say, what is the precise literal translation into Rust of this C++ code? So if the C++ code was not doing it as best as it could, I'm not going to worry about making the Rust be as best as it could. I want the Rust to be as close to the original as possible, then refactor it. Although I am sort of, like I said, I am sort of cutting a few corners here and there. Because I just know that I'm going to want an iterator out of that, not just a vector. It just doesn't make sense to make it a vector. Whereas make it idiomatic, that would be part of making it right. Should I add to here? Maintainable, readable, idiomatic. There we go. So idiomatic is part of step 2 in my book. Although, if I've said this before, if you can do 1 and 2 at the same time, then go for it. For me, though, I find it's less stressful to do 1 and then 2 and then 3. But that's just me. Hey there, Reld. Also, I didn't say hi to Kubisus. Hello. The philosophy for Rust is that 2 is the most important, and only then you need to worry about 1 while getting 3 for free, I suppose. Okay. So this is just reading, splitting it by lines, right? And then trimming the line. And if that line is an absolute, if it's not an absolute, so basically interpreting as a path and canonicalizing it and seeing if it's a file or a directory. No, it has to be a directory. No, if it's a directory, do this. If it's a file, do that. Okay. Yeah. So maybe I do want to cut a corner here because there's the read lines instead of read a string, right? Read lines. Or is it lines? Lines, right? Where? Oh, I guess I could slice the string into lines. Yeah. There's a shortcut like read lines or something, or read to lines that we had. Hey, thanks for stopping by, Jolt Jav. Have a great rest of your day. Does the /fs separator work on Windows nowadays? Yeah. It has for a long time. It's a sign of a poorly implemented program that doesn't accept /. The only things that I know for sure don't that should are like the command line processor in Windows. It's really silly too because Windows at the kernel level and up understand both forward and /. It's just some programs just refuse to use /, which yeah, why? Has it been since Windows 95? Yeah. Intoxicated chimp, hello. So in this case, doing it the Rust way. Yeah. NTFS at the lowest level is case sensitive, which is fun because upper layer Windows refuses to be case sensitive. PowerShell does? Okay. Hold on a second. Sorry about that. I think I can just say for line in configuration file dot lines, right? This should be a string, is it not? It's a oh no, it's configuration dot lines. Yep. All right, and then I want to trim them. Okay, so let search path equals standard path buff from line trim. Right? Now we have a path buff, and I can use that to see if to canonicalize it, right? Oh no, it's not exactly canonicalized. If it's not an absolute path, we take the parent folder of the file. Okay, so if standard path, can I actually say if this is absolute? Oh, I can. Right, so this is ultimately going to be mutable. If it's not absolute path, then we need to, and I should be using camel case, shouldn't I? Yeah, sorry. I fall back into using non-camel case because that's what we did in C++, right? Not camel case. Okay, so then it would be. I need to get the parent folder of that. So there's probably a method to do that, right? Parent. Oh, I shadowed it. Shoot. What if I call this configuration file path? Then I'm not going to be shadowing it. Can I say what? Okay, I think it's just confused. A dot. How come I can't use this? Oh, I have to reference it. Shoot. Parent, right? Parent. There's got to be a way to glue two parts of a path together. I wonder if you use slash instead of add. Not slash. There are some languages where you could do that. Where it was gluing them together. I'm surprised that you can't concatenate two path buffs together. Okay, well, the next best thing that I know how to do in a pinch is to do this new search path. Is that we're going to mutate it because we're going to say new search path dot push. We need to do to owned, right? Or clone. Push search path. Oh no, not to cloned. It was to owned. What's that type now? Option path. Oh, shoot. Because it might not have a parent. I better have a parent. Oh, I moved it. I moved it way up somewhere. Moved on line 33. Oh, did open actually move it? Oh, shoot. Well, I need to keep a copy of it. Shoot. Well, I suppose I could do it this way. I can have the original go here. I can just let configuration file path equal that dot clone as that dot as ref clone. I don't think I have the type quite right, do I? Yeah, I don't want an as ref. I want not into. Isn't there path.join or something similar? Yeah, maybe that's what I'm missing. Okay. I'll use path.join then. I need to read about it first. Can you open the result of asref? Because that is a reference to a path, but I need to do I need to like dereference it in order to I do, don't I? I have to dereference it and then dot clone. Oh no, but there was right, you guys were teaching me that there's a to path buff. There we go. I did it, chat. So then I don't need to do asref. Just directly do parent. All right, cool. And then let's see if I can do the path join. So that would be search path is standard path join? Or is there a path buff join? Which one's better? Path join. Creates an own path buff with path adjoined to self. Oh, so then I would do search path.join. Aha. So what I really want is that parent unwrap join search path. Right? So, to clean it up a little bit, it would be parent, unwrap that, and join the search path to that path. Just pass ads ref directly to open. Open requires a... Oh, it does require as path, so I don't really need to do that. Oh, no. Because it takes an as ref, it took ownership of configuration file. So that's why I had to make my own clone here. It consumes, the open consumes this reference. Right? It consumes the asref path. So you're saying I could have given it a reference to a reference and it would have worked too? And then I wouldn't need to say this chunk? I could have just said, I could have left that as is. You're probably right. Except for this doesn't work because this is a reference I have to do asref again. Yep, you guys are right. Yeah, so we're it'll end up copying the reference to take it, right? It'll end up taking a copy of that reference, which is fine. Because it's not doesn't need to mutate it. And we're not mutating it here either. Right? Why do you need asref? It just didn't work. It says that there's no method named parent for the type parameter p, where p is an asref of a path. It just doesn't work. I have to convert it to a reference for it to find it. Yeah, I don't know why. It comes as consuming function because they gave it a path buff. So right now we're telling it, please consume a borrow of that as ref and not consume the original. Does it need turbofish? So you're saying if I did parent what standard path reference or something? No. Yeah, I don't know. Yeah, I assume that asref is cheap. Put it before search path. Hold on, what? Yeah, that's why I needed to dereference to get to parent. Could I just dereference the reference? That doesn't work. Why? You can't dereference a reference? What? I don't understand what I'm doing. Could have done it with let path equal config path as ref at the beginning and just take it. Oh, you mean just to as ref it out? Yeah, it's probably a good idea. So basically shadow it with that as ref and be done with it and not have to say as ref here. Probably don't need to say that. No, that consumes it, so I still... Actually, hold on. No, that works because of what reason? Because this is the reference, so as ref conversion makes another copy of the reference, right? Yeah, okay, I get it. Yeah, I had that homework from yesterday. Obviously, I didn't do a good enough job. The homework from yesterday was to look up asref, and I did, but for some reason the point didn't sink in enough that this configuration file path being an asref, it's something that could become a reference, but it isn't yet until we do that. That makes sense to me now. So this gets a reference from something that might be a reference. And then once we have a reference, this is going to make a copy of the reference so that we don't consume it there and we don't have to do asref and all that junk. Okay, much nicer, right? True reference type implements deref, but asref doesn't because asref is just something that could be a reference if you needed it to be, right? You may pass an owned string, for example. It isn't a reference. Right, an owned path could fit here, and this then would borrow a reference from it, right? Did I look at borrow? No. I haven't looked at borrow. Should probably look at borrow. Homework. Study asref more and look at borrow. All right. I need to take a break. What am I going to do next, though? We're going to see if it exists or not. And if it's a directory, do one thing. If it's a file, do another thing. Ultimately, we're going to call load test suite. What does load test suite do? Load test suite opens it, reads it, loads it into the Lua interpreter, and if it's loadable, it executes it. And we can't just execute it. It has to be able to call us back. At what point do we oh, here we go. We have to do this stuff, or we have to set up a MoonUnit meta table with our own functions. I need to do that. And the most important one is this one, test, because test takes the given function and records it in our test suite somewhere. Right? Where's the given test, the given test name, and the given test suite? How come I don't see the test suite used anywhere? What? We get the test suite, but we don't use it? I don't get it. What? Why would I, that's definitely the function, right? That's definitely the test suite. So what do I do with that argument? Oh, we're storing it in our own internal Lua table. Shoot. So when do we get it back out? Oh, this is creating a new interpreter every single time we call it. Ah, okay. So then, this is probably grabbing it back out at some point. Let me find this. Oh, there's a function we passed in. Find tests. And find test goes into that table and looks for them. Okay. Collect information about the test suites and test switches registered by the test runner via that function. Okay, so I got to do all of that. They have mlua derive. Fyro is very similar to Asref. That looks like work for a macro. Yeah. Okay, I'm gonna take a break. It should only be like 3 minutes, and I need to do this because it's to avoid repetitive injury. So repetitive stress injury, like the work rave command says. And yeah, I hate Ice Train. I had it last month and it sucked. So gonna take a break, rest my eyes a little bit, and come back in about 3 minutes. Be right back. I'm back. The question, do you need to create a new interpreter every single time? I think I did that to keep the tests isolated from each other. Because that's what Google Test does. The idea is that this script could do things that affect other scripts by accident. Like these requires, for example, could pull in definitions that clash with some other tests, things that when they require. So it's just to provide extra isolation. You can expect equal control Lua error. It can be caught by runner to mark test as failed. Maybe. All right, so the I was actually thinking about this during the break. The find tests is well, not find tests. It's trace that back. Go back. Actually, right here, right? This with Lua registers Lua test, and right now, I think what I did convert these to strings because I used to take these and put them somewhere, but these actually aren't needed anymore because we're taking these same ones and pushing them back onto the Lua stack and putting them into a table. I think I did this because this is the only way I could figure out at the time how to keep this function for later, but I really don't need to do that with the Rust thing because they have a way to represent the function as a Rust object. So I don't think I need to do this business with the registry. I could just get the test suite name and the function and return them all back out. Or I could store them in Rust for later. So I think that's what I'm going to do. So I need to get there first. I need to get to load test suite. We're not quite there yet. Right now we have the search path, and we need to see if it doesn't exist, we're going to continue. So if search path exists, well, let's have it be, if it doesn't exist, continue. Can I just put that all on one line? Will anyone mind if I put that on one line? And then, why is that not, does it have to be in braces? Ah, really? Okay, fine. Braces, there you go. Be happy. If search path is directory, else. Actually, if it's not a directory, can it be something else other than a file? If it's not a directory, it's a file, right? Let me not do directory first. Let me just do the file one, which is just called load test suite possible test file and pass along the error message delegate. Right. Okay, so then we call self.load test suite. Test suite file. So that's search path. And then we're passing along the error delegate. Let's give it a name. All right, and then let me make a copy of this for load test suite. Load test suite. This is now just file or file path. Yeah, we're not doing anything with them yet. Yeah, I hope everybody's safe from Corona. As far as I know, I am. No need to manipulate stack. Can be a symlink. If it's a symlink, it's a symlink to either directory or a file, right? Hey there, Kamundi. Going well? Thank you for your suggestion from yesterday, by the way. We ended up, I ended up implementing that so that in my main now, we're using the ancestors. Look at that, Kamundi. And hi there, Strike Hex. How are you doing? Also, I never said hi to a couple people at 10:44 about the path dot join. Padota Paman. Hello. Sorry, it took me a while to acknowledge your presence. Also, Dragoneer, hi. That took like a good 20 minutes for me to say hi. I'm sorry about that. What is error delegate? In the main here, we, where is it? When we're configuring the test runner with the configuration file, we give it a closure. What to do if there's an error. Right now, we're just going to have it print the message. But I could do other things too. So this is the error message delegate. Whenever I say delegate, sometimes I mean closure or function or, you know, what to do if an error happens. So that's just the design of this method is provide a closure, call it if there's an error. So that just gets delegated. The delegate gets delegated. Hi. All right. Oh, right. We're doing this in a loop, so they can just borrow that, please. And that's a reference to... Actually, can I just do it this way? That works too, right? And then, dine? No, this doesn't work, right? It becomes a trait object if I do that. I don't want to do it that way. Can I do it with this? Whoops. No. Yeah, it's part of my, that's a trait, right? I can't both make it, so I better just do that, right? Heard you like delegated, so I delegated a delegation to delegate the delegation of your delegate. Yeah. I've been trying to get familiar with asref, yeah. But I guess I can't use asref with a... I did it again. I'm guessing that because then I would have to make this a trait object for that to work, right? Which causes dynamic dispatch, right? I don't want to do that, right? I might as well just keep it like that for now. Does this make sense to have a reference to a mutable closure? I don't even know if I have that right. Impl asref? You mean for the error delegate, right? You think I can do impl asref that? Or do I have to say impl up here? And then that's an asref. Or can I even do this? I don't even know. No. The moment I make something constrained by asref, that being a trait, this has to be a type. It can't be another trait. Unless it's a trait object. Right? Use the example man 2003 posted literally. File path impl asref e. That doesn't make any sense because e is an error delegate, not a file path. So I don't know what you mean. You should use fn once whenever possible, but I can't because there might be multiple errors. We need to call it multiple times. Yeah, so I'm using fn mute because I'm going to need to call it multiple times. Error delegate impl asref e. Okay. So again, like I've said in the past, I don't like just typing what people say in chat if I don't understand it. I don't know what this actually means yet. So what does that mean? This means error delegate is going to be some concrete implementation, some concrete type of this trait, and that trait... I see. So I can't just say E and then do as ref, because this alone is not a trait bound. But I can say that, because that is a trait bound. That is, so we have a binding, a bound inside a bound. Impl is syntax error declaring a generic argument and constraining it by something. But it's specifically saying that this will be a concrete, this is a type of bound, right? This says it's going to be some concrete implementation of that. The thing I don't quite get is what's the difference between impl and not impl? Oh, it's whether it's static or dynamic. This means it's static. Right? And so it's generic. It's a static. It's a generic that will be a static dispatch. But if I had dyne here, then it's dynamic dispatch. Some generic that implements a trait. Impl is legacy form of dyne? I don't think so. I think it means something different. I'm pretty sure that this is not going to be dynamic. If we call the error delegate, it's not going to use dynamic dispatch, right? It's actually going to resolve at a compile time based off of what I provide for E, right? They're introduced at about the same time, but I'm pretty sure dyne is for trait objects where it has to look up at runtime what the actual type is through like a vtable. But impl, it's just telling the compiler that that you can instantiate this generic as long as E implements that trait, right? Create a new type parameter. Oh, so you're saying I could have like another, like I can have EI or something here, or ER, and I could do this. ER. No. Well, I guess I don't know what you mean. But that's okay. This is fine enough. So you either need a generic or trait impl or a trait object, but you can never do argument is bound by a trait. Yeah, of course. Because it's ambiguous. Is it a concrete thing that implements a trait, or is it a trait object? Trait is not a type. Yeah, I need to add that to my list of things that are new to a C++ programmer. Because in C++, the closest thing to a trait is an interface class, and that is the same. It is a class, but in Rust, a trait is not a struct. No implementation keyword is the legacy form of dyne. Yeah, that's why when I put that out, it said it was technically okay, but it said that it's deprecated. So it knows that that's a trait object, and it says, well, you really meant to say dyne, but then I have the other problem of this, right? What is this problem? That the size isn't known. So if I really wanted to do this, I'd have to box it, or say it's not sized or something, right? Something like that. Can you even say that? I don't even think you can say that. I have to box the thing. I'd have to box it like that, and then it would be okay. But we're not going to use dynamic. We're going to use concrete, and it's a generic. All right, anyway. You don't have to box it. It would be fine as well. Well, reference, yeah. Oh. Yes. If I did that. Because the size of a reference is known. But it's still dynamic, which I don't want. Alright, you guys might hear some noise. That's okay. We'll be fine with the noise. Hold on, what? I need that in its own window so I can read it more closely. The trait as standard convert as ref is not implemented for the closure. The following implementations are found. What is the help trying to tell me? Is it trying to tell me I don't need to say that anymore? Or is it trying to tell me it's ambiguous? I don't know what it's trying to tell me. Okay, there's something wrong here. I should be able to pass the reference, right? Or not. Yeah, why doesn't that work? That should be a reference to that. I want this to get a reference to the closure so that I can call it. Maybe the problem is it's not mutable. Because, yeah, it needs to be able to change it, right? I need to be able to say it. I need to say that. But that's still, that's not exactly it. I just don't understand that. The following implementations are found. Mutable reference to T as standard convert as ref U. I don't know what the U means. As mute ref? I don't think I would want to change the signature of the closure, though. Oh, as ref is just for immutable, so I have to, what? Is there an as mute ref? Like that? Nope. Whoa, how'd I get that? As mute, okay. Nope, still have a problem. It's not implemented. I don't get it. I am lost. Okay, you know, screw it. I don't want to waste too much time. I'll figure that out later. It's just going to be a mutable reference to an E. Okay, now why is this a problem? Dang it. Cannot borrow is mutable. Why not? Why can't I borrow it? It's declared as... is not defined as mutable. Oh, like that, right? Is that the real problem? Okay, so if that maybe was the real problem, then I can go back to saying impl as mute E. No, that's not the real problem. Yeah, I don't understand this one. We're just going to use readable reference to the closure because I don't want to have to figure this out. Yeah, we're just going to borrow the closure because it's going to call it. And calling the closure changes the closure because it's an FN mute, right? So I have to do that. I believe if I just did that and said it's immutable, I wouldn't be able to call it. Let me check. Like, I shouldn't be able to do this, right? Test. It should say that it's not mutable. Yeah, so I think I have to say that. Yep. Yeah, I know at least that much. I'm comfortable enough, I think, with normal references to figure that out. The as mute, I'm just don't know it well enough to know what I'm doing or to interpret these errors. I don't know that yet. I'll learn that later. It's already on my homework. So no fear, I will study that more. But I just want to not get stuck here. Unless someone in chat gave me some insight. Not yet, so... Yeah, in Rust there's absolutely no type inheritance. That's one way which traits are not the same as interfaces, yeah. Well, there's super type, or super traits. So it's sort of like... with kids yelling. Okay, let me implement this stuff here. If it's a directory, then we add MoonUnit to it, and if it exists, we recursively call configure on that. Otherwise, we look at all files in that directory, and if they end in .lua, then we load it as a test suite. Okay, so I just grab this part alone and put it up here. All right. Okay, so let possible other configuration file equal search path dot join dot MoonUnit. All right, so far so good. You can try borrow mut instead of as mute if it works. I can add that to the list of things I want to look at later. Borrow mute. If possible, the configuration file exists. Actually, it's not just that it exists, it has to be a file. Right? If it's a directory, we're going to ignore it, yeah. So if it's a file, we're going to call recursively configure. So self.configure that. Ooh. If this is going to be called recursively, this has to be a mutable reference, right? Which means that the main has to borrow the closure. Can I even do that? I think I can if I just do that, right? That's just to make it recursive. All right, so then list directory. I did that before, didn't I? Where did I do that? I did it in the scripts program. I did that at the beginning of it, right? Oh, where was it? I can't remember now. Wow, I don't remember that. Yeah. It must have been in work. That's other stuff. Where's work? There's work. Sync. Oh, was it in the message that comes back for scripts? Here it is. Reader. It was this thing. Not sure if this is useful information for you, but the Rust standard library has a naming convention. The API is about immutable reference will be called something ref. And APIs about mutable references will be called something mute. Names like ref mute are avoided because it quickly gets too verbose. That's pretty useful. That is useful. Might want to use match because file type could also be a symlink. So if it's a symlink to a file, is file fails? No, it'll work with the symlink. It's pointing to a regular file, it will return true. The function will traverse symlinks to query information about the file. If it's a broken symlink, it'll be false. That's fine. This is what I want. False if it's a broken symlink or a directory. True if it's an actual file or if it points to one. So we're good. We good. Okay, so for path in read directory of search path, right? Right. Search path. Map directory entry to its path. And then filter that path so that it has to have the Lua extension. And yeah, just call load suite on it, right? So where did I put that code? Down below. There it is. Load test suite path. Oh, I need another bracket. Do you have Clippy Pedantic on? I think so. Well, not in this one, but in the main I did. Oh, no, I don't. I don't have it on. Let's turn it on. What was it? I can't remember now. Was the scripts that did it, right? No, which one did it? Items? One of these I turned it on. Deploy. There it is. Pedantic. Can you use 4 each instead of 4? Where was I? And runner, right? Where am I using 4? Oh, you mean instead of this 4, I could do 4 each? Oh, I see what you're saying. Just do that and then 4 each. You know, I like this. This is its equivalent, right? This gives me an iterator, this iterates it. That's fine. I think there was an alternative for instead of no, for each consumes it. No, for each borrows it and it relies on side effects. I don't remember anymore. Let's look it up. For each not well, I guess it depends on if well, hold on. Yeah, it's equivalent to a for loop on the iterator. Break and continue are not possible. It's generally more idiomatic to use a for loop, but for each may make it more legible when processing items at the end of a longer iterator chain. So that's interesting. It's interesting that it said that it's more idiomatic to use a for loop. For each does consume the item, right? But in this case, the item would be a reference, right? Each of these is a reference? No, each of these is a... For reader, each thing is a path. Oh, wait. It's for path in that. So maybe it would be more legible to have reader, unwrap, map, filter, and then for each do that. I think that's what you're saying, right? We don't need to mutate it. We're just going to consume it in here in load test suite, which should be fine. So I could do. So you're saying I could do it this way? I could say for each path self like that, and that would be the equivalent. Yeah. Either way, right? I actually think I kind of like the other way better. Because I like to separate the finding the enumeration and then what do we do after we found them. I think I just prefer it that way. But I appreciate the alternative, man. It's nice to see these alternatives. Well, yeah, it owns the thing it's iterating, so it would be mutate or destroy or do nothing at all, right? Okay, am I done? I think I'm done with this. We're done. Time to test. So I need load test suite to do something. Let's not do... Okay, that was just testing the error delegate. What's the warning here? Oh, just using it when I shouldn't. Let's have it just print something out. So, loading test suites from some file. To... Oh, right, I need to get it. Let file path equal file path as ref. Then I can do dot to string lossy. There we go. All right. Does that mean it didn't find anything? That's disappointing. It should have found something in there. Type that file. So it might not be iterating that directory correctly. Let's see what... Let's have it print some stuff out here. Let's do a debug here. Okay, and then debug here, I guess. Project on Uranium Realm server source ECS scripts test. It should be a directory. It should have gone into here. Can I do for debug path here? No. But I could do here. Okay, it never got into there. Yeah, I wonder if it's hitting here. Does not exist. Search path to string lossy there. Does not exist. Really? So it looks like it exists to me. Does exist only work with files, not directories? Is that the problem? Entity. Interesting. Print line. This search path is directory. If is, else is not, comma. It's not a directory. Is it having trouble with the slashes? Is join buggy? It's using... I mean, that should work, right? Maybe I'm wrong in assuming that it should... that should work. Well, I'm iterating from the outside to the inside of the ancestor tree. Good question. I don't remember exactly why. There was some reason why I decided to do top down instead of bottom up. It should work, yeah. So it says it doesn't exist and it's not a directory, but it is. So if I like take that string literally and do that, do you have to delimit it with brackets or quotes? And maybe get rid of the Windows NT. Yeah, so it's there. See, the thing is, I didn't even put the forward slashes in. It put it in it, right? Oh, wait a minute. No, it didn't. No, it didn't. I put that in. That's on the command line, right? Yeah, it's in the .MoonUnit file. Those slashes are present. Okay, so if it's sensitive, I guess we can just do a replace. It sucks. So, I would do a join search path and then .replace, right? Oh, shoot. It's a path buff. I guess I could take, this line before turning it into a path. I could do a replace slash. Thing is, I'll have to featureize this between Windows and hopefully I don't have to do that. That's stupid. Okay, well that was it. That's completely stupid. The slash is coming from my file. The configuration, the MoonUnit configuration file, it has these slashes in it. And looks like Rust's, what are these functions? The standard library path is stupid when it comes to forward slashes and backslashes mixed together. I have to do that, but only... well, I guess I can... no, we have to do this only for Windows, right? Well, this is dumb. There's got to be a way to prevent that, to get that to work. Rust path forward slashes Windows. This seems to think it could be or. Either slashes on Windows. But I just demonstrated how it doesn't work. If I don't do that, it fails. It does not exist. But this says it could be either. I don't... does it mean like they all have to be one way or the other? Maybe it just doesn't like me mixing them for some reason. I'm guessing that it really doesn't like me mixing them. Well, that's dumb. Every other language, it's okay with that. Windows APIs, it's okay with that. Why would Rust be sensitive to it? That's incredibly stupid. Especially when they say that. All right, well... maybe this is, I should just look at this with a positive light. This is my opportunity to learn how to use the configuration stuff. There's a way to do like code that's only needed for one operating system, right? So like if I said fix, and then I made like impl, you can add functions to a structure, right? How is that done again? How do you add functions to an existing structure? Like add-ons. Can I just say impl standard path, and then say function fix self, like this? Define a new trait and implement it or something. So can't I? Okay, it's not going to let me do that. So you say I can implement a trait and then implement it for path, right? So I would have something like trait fix path silliness, function fix self, and then implement fix path silliness for that. All right. What does it not like about this? Okay, it's just not returning it. So then it would be self dot what? I can't do replace. Is this, do I need to do path buff and not path? Oh, this is for strings. Yeah. So replace / with \. And then I can just say, okay, that didn't quite work. Oh, it's for slices, okay. Can I say slice there? Found string. How did it find string here? Is replace a method only on string? No, it's a slice thing. How did it find string? Found string. Where is it finding string? Oh, this returns a replace returns a string? Yeah, that makes sense. Replace. Why am I in this one? Replace. Yeah, returns a string. And I need to say that up here. Okay. And then I need to make the whole thing within a config, right? And I don't know how to do that yet, but I've seen that in other places. Just search for it, I guess. So Rust CFG Windows. Was it in Rust by example? They had it? Here we go. So I would say CFG target OS is Windows, right? And then would I repeat the whole thing again, but for Linux, Unix? I'm gonna say not equal to, and then it's just self.toString or string from. Okay, so you can't say not equal to Windows. How do you like Rust so far? Pretty well. There's just some, I guess I'm going to be adding to my list of things I don't particularly like. We just learned one. the standard path methods on Windows do not let you mix slash and, well, mix slash and slash in the same path. Unlike pretty much any other programming language. Alright. So I have to do this ridiculous fix. So I can't say not equal, apparently. How do you say not Windows? Oh, not. There we go. Not. Okay, so if it's on Windows, we have to replace the slashes. On any other thing other than Windows, we don't need to worry about it because they don't use backslashes in the first place. Alright, so that's my fix. I should probably call it something other than fix, right? How about we call it fix silly path delimiter. I don't know. Fix silly path delimiter nonsense. There we go. Can you return cow to avoid allocation on Unix? Oh, instead of string, return a cow string? Yeah, maybe. It's standard. What's cow in, actually? Mo. Cow is in borrow. Is that how you use it? Whoa, this happened again. Something wrong with the CSS, I think. Okay. So I just have to wrap it. Like that? No, we can't say into? Dang it. We can't. We can't because of that. Normalize path delimiters. See, the thing is, I call it nonsense because they're the only thing that requires path delimiter normalization apparently is Rust. The operating system doesn't. I can, in any other programming language, I could mix the slashes and the backslashes and it just works. It's only Rust. So I don't even think, so it's cow, oh, so it's slice. And I have to give it a lifetime? Really? Do I? I can't just say slice? No, I got away with it without saying slice, except for this, because I changed it, right? Fix path silly. Path delimiter nonsense. Oh, except for I got the wrong type out of it. Okay, you can't go from a cow slice to a path buff, apparently. So, but I can go from a string, right? There we go. So that's a consequence of using a copy on write slice here. Is I have to, because this gives me a string, I had to move it into a copy or write slice, and then I had to go down here and do a, I had to move it into a string first. I'm losing my place. Where am I? I had to move it into a string first because pathbuff doesn't take a copy or write slice. Do a string in the copy on write? You mean instead of string from, isn't it the same thing? Or instead of in the into? Isn't it the same thing? As string, not string from. Yeah, isn't it the same thing? Am I wrong? I don't know. Is it not the same thing to do as... I can't even do as string. Nope, can't do it. There is no as string on copy or on write slice. Just borrow the slice from the... Well, we can't do it. There's no associated function with the name as_str for a copy on write slice. As ref. Now let me understand what we just did. That did work. Hey there, Ereld. You had an electrical failure. I'm sorry to hear that. String from does allocation, but this doesn't, so I eliminated an unnecessary copy. Okay, but am I making a copy here when I do into? Into shouldn't make a copy, right? It does perform a conversion. It consumes the input. One should avoid implementing it, but prefer using it to ensure that, yeah. I'm hoping that this doesn't do another allocation. Hey there, Bonfire. And how are things going? Haven't checked in since I started working on Rust. Current state of the engine. Engine is sort of on hold now while I get better at Rust. So I'm, every day running into new things I don't quite know about Rust. Today it's I'm fixing silly things in Rust about path delimiters. Apparently you cannot mix backslashes and forward slashes in the same path. Rust thinks that that does not exist, even though it does. To fix it, I have to normalize the path delimiters. That's okay. We can live with that. It's probably just some silliness in the Rust standard library. See your last message. Your last message was just figure out why mixing slash and backslash does not work in Windows Path. It's because they are in the canonical form. The code seems to explicitly behave differently if it's a normal Windows path. Okay. I mean, I don't really like seeing that weird canonical form anyway. I wonder if there's a way to get to... The reason why that happens is because I am doing... where is it? In the main program, I'm doing canonicalize. And this turns it into that form. But I only wanted to use canonical to make it absolute path. If there's a way to make it absolute without making it like the true canonical way, then I'd like to do that. You don't think changing the form of path helps? You use the components iterator on the joined path to divide it, push the components. Yeah, well, that's... What are the benefits of using Rust over Lua? I'm actually going to continue using Lua. It's the Rust. Rust is going to replace Python for me completely, and then it probably would replace C++. So that's what I'm doing today, is I'm replacing this C++ program with this Rust program. So, like, this is that in Rust. And that's as far as I've gotten. I haven't actually gotten this tool to actually call into Lua yet, but we're going to continue using Lua. There's some method to change the path specifiers into the main OS ones, which are chain... Well, yeah. Well, we'll just... Until I learn how... Until I learned, this was a convenient excuse for testing out this kind of thing, right? Where we have target-specific code. That's useful to know, at least. So I haven't said hi to Vizara yet. Hello, and not for Benny. You're also here. Hello, Storm Dragon is here. I'm looking for your chat though. I don't see it. The Swiss and Storm Dragon. Hello, I found your chat. Hi. And Sprudeldel. Hello as well. Where's your chat? I don't see it. 1111. Is the return value has slightly different semantic? Okay, that was a while ago. Sorry I missed it. There it was. Unlurked to answer questions. Happens to the best of us. You try to lurk in the stream, and then you're like, I need to say this, even though it's going to unlurk me. Oh well. Let's hope the streamer doesn't notice. All right. The place where splitting a path looks at the path separators is there. Okay, let me copy that for later. I'll figure out that nonsense later. So the benefit of Rust, I have summarized in, what is it, why Rust? The challenge of learning it, it's a difficult puzzle, so I like difficult puzzles. It tends to guide you towards making good designs. So in C++ and C and other languages, you can get away with like a lot of just poor practices that could end up being bugs, or you might be able to get away with it if you're lucky. Rust tends to be, since it's super strict, it tends to guide you towards making a good decision, because the good decision a lot of the time is the only way to make the compiler compile this stuff. Hey there, C17R. Yeah, and then I'm finding this true most of the time now. Most of the time, once I get it to compile, it just works. There've only been a few times where it didn't. I really like that idea, because the I have another dev note, order bugs. If you can catch a bug before you can write it or during compilation, it's the best. So in C++, what I'm finding, most of my bugs I can test if I can find them in unit tests if I have them. With Rust, I'm catching a lot of them on step 2 before we even get to running it. So I like that. The sooner I can catch a bug, the better. I never want to get 7 ever again. I'd rather not test things manually. I'd rather at least have unit tests, if not catch them during compilation. So yeah, so far, forcing me to be very to do it the right way, because it's so strict, is getting the program to work usually right away after it compiles. It's pretty sweet. The hard part is actually getting it to compile. I like to think of it that there's not just a learning curve for Rust, there's a learning cliff or two. The boss tells you leave that toxic place. Yeah, well, you know, it was all tongue-in-cheek, right? Anyway, yeah, you want to try to catch bugs earlier. Rust, since it's so super strict, you tend to find it like this. When you start misusing variables, the compiler says, "Oh, wait a minute, you can't do that," and you're like, "Okay, fine, I'll fix it now," before I even finish writing my code. Okay, so this is working now, right? Yeah, so now it knows where all of my Lua tests are. That was good. The next step would be to actually load them into Lua and detect when the tests are called. So I'm going to do that next. Maybe get rid of these debugs that I had in here. So Shift home, no, Control home, and then Control F, DBG exclamation point, and then delete that. And there's another DBG. All right. Was there a third one? No. Just removing the debug statements right now. Okay. We probably don't need to see this anymore, right? So that was all done in the main. And configuration file one was up here. We don't need that. You can do path.components collect to normalize the separators. Huh. So that's basically splitting it out and then rejoining them, right? Wouldn't that be... It's just doing fix in a different way, right? But it's letting Rust do it instead of me doing it. I guess that's maybe one step better. Yeah, it's really super useful. Basically, wherever you have an R value in Rust, you can slip a debug around and it'll print it. So like I could put it right here if I want, right? DBG. Hold on. No, I can't do it when it's a call like that. It has to be an R value. So like, but I could do it here, for example, right? Whoops. Hit the wrong key and I fly off into outer space somewhere. Yeah, you can put that anywhere, and then whenever it hits that line, you get that, you get where the debug was, and then what it was, and then even what its name was. Pretty sweet. All with macro magic. So it's kind of like the step away from debugging. Rather than showing in a debugger, it's actually doing a printf for you. But you can embed it anywhere. You don't need a separate statement for it. Okay, let me get Silmeth's idea. Maybe I'll do that when I refactor this. There's also a ticket for canonicalize returning paths. Sometimes probably. Oh, so there already is one. Maybe I should +1 it. Let's follow that from Commundi. Is this the problem that I ran into today? And a lot of software doesn't support UNC. That's not exactly the right... That's not exactly the same problem. Can't pass the UNC path as the current directory when starting a process. Oh, really? So this is a slightly different problem then, right? So maybe I just should avoid using canonicalize. If there's some way to get the absolute path that doesn't do UNC paths, maybe. Or are they saying that, like, in order to make absolute paths, you have to use canonicalize, and it does UNC paths, which we'd rather not have? Huh. It's a long discussion about it. I don't want to read the whole thing right now. Actual debugging is very simple in VS Code. At least write a test, click the margin to set breakpoints, and click debug. There's one extra thing that I had to figure out, though. It was in the settings. You have to set for debug allow breakpoints everywhere to true. If you don't set that, and you happen to be using a C++ debugger, it's going to say, I have no idea what this Rust file is, but I'm not going to set a breakpoint in it. See, watch what happens if I just remove this line, right? And then I try to set a breakpoint in my Rust. It's like, actually it worked. Wait a minute. That shouldn't have worked. Okay, maybe I'm wrong. One point I had to set that because when I clicked this, it wouldn't do anything. Okay, obviously, this is not what I thought it was. What if I set that to false? Maybe it's because I need to reload. Anyway, at some point I had to set that because it wouldn't accept my breakpoints in Rust. Anyway, maybe they fixed it. I don't know. Let me get back to this. What does my current task say? Writing code to enumerate test suites. So we did that. Next, I want to actually... No, it's not enumerating test suites. It's enumerating test files right now, which is not correct. This is a file that potentially becomes test suites. It's loading test suites from that file. Now, yeah, I have to actually do it. Someone made a crate just for the Windows path issues. They called it dunce. That's funny. Okay. Thank you, Commundi. Also, I should thank Silmeth again. Use display instead of two-string lossy. Well, for printing it out to the user, maybe, but I think I didn't want to use display for using it with other APIs. I think with display, well, it's doing the same thing now. I had trouble before, though, with this... Wait a minute, hold on. It's not what I thought. How is this different from string lossy then? Oh, this is if it's destined to be displayed, right? But you can't take that and give it to an API. So yeah, sure. If I was going to display it, but in other places where I do toString lossy, like, well, here we can do display, sure, and here we can. I want to see where we use it with another API. How'd we end up here? Oh, right, because I had it open. Okay, so close it. Oh, I guess I'm not using it with any APIs. I'm only using it in this other program. Okay, well, now we're not using it anymore. String will allocate. String will allocate. You mean string new? Or string from? Or toString lossy allocates? I think that's what you're saying, right? toString lossy allocates? Can I trace it down into that? Control click is not working. And we can't even see where it goes. It looks like it might not allocate. It's making a clone on write. So it might copy. It might clone. But it might not. That's what a clone on write does. It's like, you might get a clone, might not. All right. I probably should take another break. I need to get into the Lua stuff. Thank you for the follows, by the way. Allocate only if your path is not UTF-8? Yeah, probably. But then display is not, right? It's holding on to a reference that lives as long as the string itself, the path itself, right? And yeah. I'm getting too distracted. Stop getting distracted, Ramu. Can theoretically avoid allocation even if there is an invalid UTF-8 in the path? Huh. All right. Load test suite. What does that's what we're on now, right? What does the C++ do in load test suite? I need to go to runner, actually. Load test suite. So this stuff. Copy this over to runner here, and we're going to paste it. I wish I could paste and select at the same time. All right. Don't need that. Okay. So we actually are going to call the error delegate if we couldn't open it. So that means we're going to do let file match, right? No, yeah, let file equal match file path standard fs file open file path. Okay. No, hold on. It wasn't match. It was Why am I trying to guess? I should just look at what I did up here. Oh no, I had to do a match. And I had to do that. Okay. Error. And then here, do I actually do an error? I actually don't care about the error. So this does two things. It calls the error delegate with a format. That is the path. And then return. Why is this giving me trouble? Oh, because I don't say match. Match, not math. This has to be display. Okay, what is wrong with this? What? Mismatch types expected oh. That? Yep. Okay. I wonder if I could improve on that error delegate to make it not do that. It would be where this configure's defined. Like, that could be asref slice or something. I'll do that later. I'm not comfortable with asref yet. How to add libraries to GCC. It will usually return an option to use question mark cover instead of match. I'm sorry, I'm not following you right now. Okay, so we get a file. What are we going to do with this file? We're reading it in, right? And then we're going to evaluate it. So, is it again file? Script. Let's script equal file dot read. Oh, and it was the other way around, right? Let's script. I can't type right now. Script is string new. And then file dot read script dot how did I do this before? Is error with an if, and it was read to string. If file read to string mute is error, then it's a similar kind of deal using the error delegate. I know you guys don't like me using an error delegate. That's just the way I did in C++. You guys probably want me to return a result. Maybe I'll turn it into that eventually, but not right now. Just doing a straight port. Okay, what did it not like about this? Oh, because that's not mutable. Probably neither is the file. Yep. What's wrong with this? You seem to be trying to use mesh for destructuring a single pattern. Try what? What is it trying to tell me? What? Oh, there we go. Consider using if let. Is that because I didn't know? There's a return in there. That's why I can't use an if let, can I? I can't use an if let with the return. Found on Museum Stream the excellent VS Code extension error lens, which displays errors and warnings in line. Well, Museum is better at Rust than I am. Let me look at that later. Error lens, huh? Get prints a usage example if you let us scroll down in the Clippy warning. Oh, try this. Let file equal if let file. Oh, I see what they're trying to say. I never thought about doing a double assignment like that. Let me try it myself. They're saying if let equal. No. There's no if on the left. It's if let okay file, right? Equal that, then file. Error. Else, because I'm not using the error, I just do that. That's what they're trying to tell me. And then I do need that because that's for the let. Let's see, is this easier to read? And I kind of want to, even though I'm doing excessive new lines, I kind of want to do that for now. If let mutable file equal, if let okay file, well, the way you're supposed to read this is if opening the file destructures to be an okay, then with that file yield that file to there. Otherwise, we're returning, and since return has the type never returns, it can fit in the context of that let because it never actually returns there. Hey there, 2H Strike. Syntax is very easy to read, by the way. Which syntax? Their syntax? I struggle with it. Hello. Thank you for the follows, by the way. And hello, really Frank. How are you doing today? Don't know how well the error lens works with super long rust errors. Huh. Well, we'll have to give it a shot. Just doing some straight Rust porting here. So this, we just ported all of this from C++ to Rust, right? Okay, so we've got the equivalent of getting the script in. Next, I want to get a Lua context going, and with it we're going to run the string as a script and give it a closure as a callback. So, how am I going to do this in pieces? It would just be a global with Lua. I'll just use the same kind of syntax. It's going to be a closure, which is given what? Given nothing. Hold on, then what? What the heck? What does that do in C++ there? Where am I? I need to go to runner, actually. Here I am. So what does that actually do? Okay, there is an argument. No, that is the argument. It's to run that function when. Right here. And that function does what? This. Oh, it's in the self, and it's in the state. Okay, I don't really want to do that, right? This stores it in the state. Yeah, we don't want to do that. So I think I just want to pass it in. So Lua. And what does with script do? Calls the given function after executing the given Lua script. Yeah, that's what we want. Okay, so then it's going to be the same thing. With Lua, with script. I guess this mode where we would return an error message would be like having a result, right? So then I could do the same thing. I could say, what was I doing with the file? Is error, right? If with script, and here we need the script and the file's path, which is this one, and then the closure. Closure here would be, actually no, if I'm using bind, okay, yeah, I do need a closure because I need to close on, I need to borrow script and file again, so this would be, I don't know if I need any arguments here, but this will probably be self.find tests script file path. Something like that. Is error. Oh wait, no, we need the error message, so I need to do, okay, I can't remember this. Error lens is just the F8 you told me to use? Yeah. This thing, right? But I don't have an error lens plugin, so I don't think this is error lens. This is something that's more primitive. If let is just like let, well, it's with a match though, right? And it's conditional. Okay, what I want to do here is the equivalent of this. If there is an error message, return early, but I want to do something with the error message this time. So, without thinking, I know I can do it with match. I could say, okay, and that does nothing. If we have an error, then we're doing something. I'll just let cargo clippy tell me how to do this better. Okay, so we're going to call the error delegate again and return. Right? And this error is going to be unable to, it's going to be this string. Let's collapse that so you guys can read it. So then these are both replace some pattern. And here it's what? The file path and then the error message. And I don't need a return here because this doesn't do anything else. These don't exist yet. I need to make those. Okay, so let's just define with Lua. That can be completely outside, right? Yeah, I can put it right here with Lua. And then this should be an FN once, right? How do we do this? It has to be a generic. So F where F is FN once, which is given the Lua interpreter, which I don't have a type yet. What if I just well, I should just figure it out. What's the type of the Lua interpreter? The other program has it. It was one of these. All right. In fact, I can just copy from that other project, right? What did I have an R? Oh, because it returned a result. Let me just copy this whole thing. I don't need a well, I guess we can keep it generic. What was I doing with that result? Oh, I was actually doing that stuff. Okay, I don't need a result here. Let's simplify. That doesn't do anything. And we just call it. But we have to make the Lua. That's the part that's missing here, right? This doesn't exist here. It exists in here. So let Lua equal mlua lua new. Borrow mutably the interpreter. That's good for now. I just want to see that it actually gets in there and resolve these other errors first. You can use Control Plus to make Rust Analyzer define it. Really? Control Plus. No code actions available. Control Plus. Nope, I don't think so. All right, so with script. What was that for? Okay, this is just another wrapper, right? Where is that function called? It's called right in there. Okay. I think again, though, we're going to want to give it the Lua interpreter, right? Because this is probably, this find test is, where is it? I'm in the completely wrong place. With script. This find test assumes the Lua interpreter again. Okay, so yeah, so I can just make another wrapper with script. With another function. And in this case, with script gets some other arguments, right? Script and a file path. The script is, we'll just make it a slice. The file path is already a reference, so a slice, a path. Okay, so a slice. So script is a slice, and the path is, so these are different lifetimes. So okay, I can just let it use implicit lifetimes, right? Standard path where f is once mlua lua. We'll fill this in later. Hey there, Batcraft. How are you doing? Doing some heavy thinking and porting. C++ to Rust right now. Control Plus to generate a definition with script. Oh, I've already done it. So you're saying I can go down here to where it's find something doesn't exist yet, and I can hit a Control Plus? And it just doesn't work. No code actions available. This, it's expected to take an argument. Wait, what? Oh, I didn't do that right. No, I did it right. Why? This says this takes 3 arguments. Why does this say it only takes 1? Oh, the closure is expected. Okay, right. So this is Lua. And we'll give it the Lua interpreter. It briefly showed it. Yeah, I don't know. I moved the cursor around a lot. What? Okay, I'll test your theory by commenting this out. All right. So now it's commented out. Now it's not going to know what with script means. So Control Plus. Oh, it's generate a with script function. Ooh. What did it do there? Didn't quite do the right thing there, did it? It didn't get the types right either. I think we're not going to use that. It really didn't know what to do. It got really confused. Okay, I need to find tests within this structure. Yeah. Right here alphabetically, right? Find tests. So this is given a Lua, which is a reference, mutable reference to an mlua lua. And what else? The script and the file path. So similarly to, so it gets these two also. And I don't think it returned anything, right? Right. Is this going to have a problem because it's I don't have self. This might be a problem. Let's borrow immutably from... I wonder if I'm going to have a problem with it borrowing here. Okay, yeah, so this is borrow that script. Actually, yeah, borrow it for the same reason there. Oh, with script is supposed to return a result. Okay. Result string. And okay for now. Oops. Mute Lua. Okay, now we're all good. Wait. How is Lua here on... Oh, with script should have... Oops. We need to pass the Lua interpreter to it. Yep. So you get the Lua. Because, well, let's just call it F Lua. Right. How's debugging closures? They're okay. I'm getting better at closures just knowing that both closures and asynchronous functions have to, you have to be careful what you capture. They have to be, they have to live as long as the closure is gonna, or the asynchronous thing is gonna last for. So that's why I'm worried about this self. If it needs to mutate self, it's gonna borrow it within a closure. I don't know, let's see what happens if I had to make that mute. Is it gonna give me some problems? No. But probably because I'm not using self after doing that. Actually, it just might be okay just because. All right. So that gets us down to just this part here. What are we doing here? Finding the name, it looks like. Getting the name of the file without a file extension. Ecton Dev, raiding me with the party of two. Welcome back, Ecton Dev. And hello, Domson. Haven't been here much recently. How's the data migration? The data migration is almost done, but I haven't been doing it on stream, so... Database. Why? Oh, here it is. Here it is. I've done all of the create and update and delete, and then the select is I'm down to 5 different components. And then once I get these 5 done, and then I have to do the initial. I have to put in the code for initial database migration, and then it should be done. We should have all the data in a SQLite database at that point. But this stuff was really like stressful to do on stream, so I've been doing it off stream. Yeah. See my task? Writing code. Does my task explain why to go to Rust? The why Rust is mostly because people have been asking me about it, and I've been really liking it. So why I like it. It's been a challenge and a difficult puzzle to learn it, which I like, and I think it tends to bend you towards making good designs because if you just do sloppy code, in the end, Rust will just complain that you're doing all sorts of things wrong. And then I really like that my code tends to work a lot more often after I get it to compile than it did in other languages. Oh, why am I doing some C++ Rust project? Yeah, it's that the Rust is new for me in the last month and a week. And before that, I've been working 2 years on this project. So established a lot of code in C++, Lua, and Python, and JavaScript. And now I'm looking to incorporate Rust, and to get more practice in Rust, I'm taking these one-off parts of the environment in which I'm developing the game and porting it to Rust. Both for practice in Rust and also maybe I like it enough that going forward I'll be doing more stuff in Rust and less in these other languages. The third point's the one you've been appreciating lately. Yeah, once you get... The compiler basically guides you towards a really good implementation, usually. And so as long as you gave it a set of a code that is what you actually want, then usually just works. Yeah, rather than try to port my entire game engine over to Rust, I'm just taking things that are small and independent and porting them to Rust. So the thing I'm doing today is porting the runner for my Lua unit test. So here's like an example of a unit test in Lua. It leverages a special test runner that I made called MoonUnit, which is written in C++. So it's a small little program that just hosts the Lua interpreter and both discovers these tests and runs them when it's told to run them by the VS Code plugin that normally works with Google Test. So my test runner impersonates Google Test. It prints output that looks like Google Test so that the test, so that the extension VS Code thinks it is Google Test, and when in fact the actual tests are in Lua, and it's pretty cool. So the program is standalone and independent, and yet used along with my other tools to build the game. So I'm like, hey, let's try porting that little tool to Rust. So that's what we're doing today. So the work is mostly the program has to locate all of my Lua unit tests, collect their names together, and then when told to run any specific one, it needs to do that. So that's what we're doing. Right now I got it to the point where the tool will print out the names of all the Lua files that have tests in them. So the next step is to actually send them through a Lua interpreter to gather what the actual tests available are and get that list. And then once we have that, then the final step would be, given the list of Lua files that we know of and the list of tests, when we're told to run one of them, actually run it, and then tell us if the test passed or failed. So, for example, like if I make the test fail by messing up that number and run, I have to hit save first. Run. Then I want the Rust port of it to do the same thing. It should run the Lua, it should report that a test failed, and give me a stack traceback. So right now this is being done by the C++ version of the tool. The Lua version is a little bit behind. Let's close that one. Yeah, I need to take a break. Hold on. I want to get to a stopping point before I take a break. So I want to get it to where it's actually finding our tests. So with a Lua interpreter, read in a script, and with that script, call that. And if reading the script has a problem, we're going to end up printing well, calling the error delegate, passing along this message that we were unable to load the script. And so that covers down to here, and then this part I haven't put in here yet. I was just trying to find out what it was doing. I think it's just getting the name of the script. But what does it do with it? I don't even know what it does with it. Is it just throws it away? Let me find out where that code was. I guess I can just search for that. That's one way to find it. What are we doing with this name? I think this is all a waste. Because if we figure out this name, right? We're not doing anything with it. Not doing anything at all with this. Why do I even have this name here? This is all dead code, isn't it? So this is another thing. Like, Rust would tell me that this is dead code. The C++ compiler IntelliSense will happily do this even though I never use this name after setting it here. Right? And there's no side effects for depending on here either, right? Yeah, it's just finding the name part of the file and then nothing. So I don't even think I need to port that. This is done, right? Don't need to do that. With Lua really bugs you? Why does it bug you? Oh, I guess I could condense that. There's no reason for me to have that extra indentation. And that would just be collapsed with that. Isn't there a Clang flag like warning unused? Maybe. But the fact that I would have to go search for that and figure that out is a chore, right? Whereas with Rust, all I need to do is in one place say, hey, give me, where is it? Give me lots of warnings. Be pedantic. That's all I need to say. Okay, so what about the with Lua did you not like, man? The point of this is to make a Lua interpreter and to pass it to a function. Do you not like that I'm doing that? Because I want a different Lua interpreter every time this load test suite is called. It needs to make a new Lua interpreter and call that for it. And I think the reason why I had that as a separate with Lua function was because I call it more than once. Yeah, there's like 3 places I use that kind of thing. Imagine if Rust creators discovered debug flags, there might not have been a Rust. Or compile flags. That does sound right, Ereld. Warning for unused code, yeah. The other thing that this with Lua needs to do is make the FFI between Rust and Lua, right? All of these things that the Rust code is going to call, we need to do. And that's the most important one. So I need to make a function and attach it to that Lua context before calling this function. So that I've done before, right? Let me find it. Where am I going? I'm going here. There was one where we made a Rust function that Lua could call. Where was it? Oh, here we go. I want to call Lua create function and then set it. But I don't want to set it in a global. I actually want to... oh, no, maybe I do want to set it in a global. What did this actually do? Oh, no, it didn't put it in a global. It made a meta table. So I need to find out how to do that. We need to make a meta table called MoonUnit. And I think this makes it index itself. Okay. It's actually these two, right? New meta table, then take the indexer and index itself. So, right, so if you took the meta table itself, that we're eventually making it a global, right? Where do we do that? Where do I set it as a global? At some point there's, or maybe Lua L meta table does make it global. I think Lua L meta table makes a global object, which is a meta table. I think that's what it does. Oh, no, here's where it does. Okay, no, so we have to do that at some point too. I have to make a meta table, I have to set it as a global, and that meta table has to have a method called test. Why can't you return an interpreter with Lua? Why would I want to return the interpreter? I want to say with an interpreter do something. It's the visitor pattern, sort of. Well, not really, but what I'm trying to say with Lua is saying do that with a Lua interpreter correctly set up for us. Actually, now that I think about it, this has to be within the self because we need to borrow self to be able to put stuff in there. Yeah, I'm going to want to move these into the runner, aren't I? I might as well do it now. Put it into the runner. It would go down here. And this would have to have mute self on both these guys. And when we call it, we got to do self dot. And now I have the multi-borrow problem that I thought I would run into. It's just a matter of time. I just need to reason about it. It's because I'm making a closure that's borrowing it again, right? I probably want to pass it through. So like, here. We can't use that though. Shoot. Can't use that's a reserve word. Runner. So this would say, can I say self there again, or do I have to say runner is, well, no, I just say mute runner, right? Mute self. And then would say self comma, or self dot. There we go. All right, and then, yes. Let's just silence these for now. Given a runner, let me fix these other things here. I can't borrow from self here again, so I'm going to want the runner back in here again. So again, this one takes the runner as well. And then, again, self. All right, cool. Where was I up here? Right. No, where am I? Where am I? I'm lost. Right here. Oh yeah, Mrs. Reimer was asking me last night if I have a way for people to find out what the commands I have, and it's on my list of things to do. I never get around to it. One of these days I'll make a help with a command so you can get a list of commands. Right now you just have to sort of guess, or maybe if someone else knows what the command is. Yeah, sorry about that, JT. Just try to return interpreter once it solves the borrow problems. Well, but so does like having it run through, having it pass through its own borrowed reference. It's saying do this with Lua interpreter, right? And it's just we get the borrow if we need it, which we do. And the same thing with script, right? It's just a different way of doing it. But maybe it's not idiomatic Rust. Maybe I just need to learn how to do that. I still need to take a break, but I'm not at a good stopping point yet. I want to at least have it run Lua and get an error out. Yes, so let me, actually this, well, hold on. So this needs to actually load the script. So maybe that's what I'll do, and then I'll take a break. So given a script, do I need a path? Oh, the path, I used the path, right? With script. What did I use the path for? Oh, to find the file. Yeah, of course we need that. Oh, no, wait a minute. Why? Why? Oh, because we need to set the working directory. Yes. Okay. So we're going to have to do that here too, right? So we need to remember the current working directory. We need to change the working directory to the path of that file, because the Lua interpreter itself may look at the file system. Then we're going to restore the current working directory when we're done. So how do we do that? I know how to do path parent. How do I set the current working directory to that, though? I'm going to guess it's something like standard OS, no, standard IO set. I don't know. I've already given up. You take a break at work, you break your code with a bogus syntax and a comment saying the words in your mind, it stops it from compiling or remind you what you're doing. That's a good idea. Would move keyword help here? But I don't want to move things into that closure because then I wouldn't be able to call it more than once. And I'm doing, oh no, actually I'm only calling it once. So maybe I could move stuff into that closure. So maybe, I don't know. But right now I want to look up Rust change working directory. Okay, it's env. I knew it had to be something. Set current directory to the parent, but I need to get the it's probably a get, right? Get or a currenter. Why would that have a result? Let's just unwrap it. Why would it panic? Why would current_dir panic? Invalid? Why would that be? Current directory does not exist. Insufficient permissions to... Okay, we're not going to run into that. That's fine. So unwrap that, and we want... what do we get from that? A path buff. Okay, great. Let... I'll even use the old name. What was it called? Original working directory. Equals that. And then at the end, we do standard env. Set back to original working directory. Done. All right, that's that part. Ooh, what's wrong here? I have to unwrap that. Okay. And these can fail? Okay, fine. Unwrap that. Seriously, all of the, like, unnecessary checking. Might as well panic. It'll never happen. I say this, and then, like, Future Rhyme was going to be like, it panicked. You should have checked it. Okay, so... It's really just loading and running it, right? Loading it, executing it, then doing the function, then restoring the current working directory. So that's it. So I already did this in the other project, right? I did that's lua.load. That's this stuff, right? In here, lua.load script set name to be what do we end up setting it here? Equals plus file path. So that would be how do you do something like that in Rust where you take a constant string and concatenate two strings together? Just unwrap everything like presents. Yeah, they may or may not explode. I want to say like equals plus path, but it's never going to let me say that. Oops. It's never going to let me say that, right? So what do I say in here instead? Oh, also, actually, we're allowed to, at any of these points, break out early, right? Yeah, I think I just need to convert these. These will not convert, right? If I just set the name to the... Let me fix these other errors first. Borrow that. Oh, here I have to do how about display? It really doesn't like that. Do I need to borrow it after converting it? Come on, what does set name need? It needs something. What? What the heck? Why is it so generic? S. I don't know. You would think that then it would just be able to take a path if I just let it borrow it? No? Come on, man. It needs to be U8. Okay, what do I just say? Displayed. You would think that I could just do that and it would accept it, but it's having trouble. It doesn't like, it wants to see a array of bytes. Does this have to be a two-string lossy after all? Without that, maybe? No, come on, man. Expected a reference. All right. Two-string. I really shouldn't be guessing this stuff. I should just know. Wait a minute. There's an that's an option? Finally. What, and so that's, yeah, so that's what I thought two-string lossy did, but it didn't like that one. Because it was a clone on write. Do I need to do like as ref or something? There we go. Okay, fine. Seems silly, overly generic to have a function name, set name that doesn't just take as, yeah, isn't that kind of weird? Well, I tried the reference in front and that's not good enough. And I kind of see why. It just doesn't, it doesn't know how you want to convert it, right? It's like it's a copy on, a clone on write slice, and it's like, I don't know how to make a slice out of that. Actually, shouldn't it be able to figure that out? Or maybe it's this, that it's ambiguous. I don't know. Anyway, I need to resolve these. So the problem here is that the result type is different, right? There was a trick to convert it, wasn't there? It was to like make this an error. No, what was it? You just stick as bytes at the end to explicitly say you want it. I mean, I guess. Won't that as bytes? It's the same thing, right? As slice as. Oh wait a minute, no, it's not the same. Huh. And versus as ref, which does what? Which gives me something that's convertible somehow. What's better then? As bytes maybe? Because they explicitly want something convertible to as ref u8 array. I guess, I don't know. Yeah, they're slightly different, right? A string slice is different from a byte array. Yeah. How do I convert? There's a way to convert these, right? I forget how to do it. I think it's that the type I made here is not implicitly convertible from this one. Yeah. Convert from mlua error is not implemented for string. It was like map. I didn't do a map error or some junk like that, right? Yeah, map error. But I don't want to have to do it twice. That's the thing. What if I implemented it for them? Could I implement that for mlua error to convert it to a string? I'm surprised they don't actually implement that. As ref gives you reference to whatever is inside the cow. As string slice gives you string slice. As bytes gives you a byte array. As something, okay. So this is technically correct then because they wanted reference to an array of bytes, and this is saying, yeah, we want to do the UTF-8 check, and then we want it as bytes because that's what this needs. Cannot implement it? Bummer. But I could have an intermediate, right? So I could say, how do we do this? Let Lua result equal that. And then, that's interesting. Why doesn't it not let me do that? Shouldn't I be able... Oh, without that. There we go. That doesn't work? Huh. I thought for sure I'd be able to get, like, the mLua error, or the result mLua error as Lua result here. My own error type? Yeah. I need to take a break. How did this work in the other project? We basically did that. Oh, is that the missing part? I need to say if we get here, it's okay. No. Oh, but okay, this won't work because this does a return inside. If I made that into its own function, then it would work. Okay, let me just back up. We'll just do the map errors for now. Fix it later. Dot. Do I have to do the dot map error twice? Actually, no, I don't have to do that, right? What would they... No, I do need to do it. I have to do the map error in two places, don't I? But I could do the map error in one. I could get the closure I give map error, I could... Oh no, it's only, I can only call it once. Still might be okay, right? Okay, let me just type it. If you want a Lua result, then you can use that. And then no, I just want to turn it into a string. So it's I want to say error dot to string, I think, and then question mark it, and then I need to do the same thing here, right? That's what I wanted to do, but I don't like this redundancy. So that's why at first I tried to capture the mLua result and then I was going to map it once. But I guess I could also just put that into its own closure. Let map Lua error equal that, and then call that twice. Can you do that? Okay. It's not smart enough to see that, apparently. Okay, forget it. I need to take a break. Could be easier to and then map error to remove the repetition. So you can say, you're saying I can do and then exec, right? So here the operation, it's a what is the thing actually? What does load actually give me back? It is a chunk. You're saying I can do that, right? And then get rid of that. Redundant closure found. So I could just say exec. No? Let me let Clippy tell me what to do, and then I'll take a break. I'm really tired. Oh, I could if I was explicit. Okay, got it. So I can say mlua lua chunk exec. Oh, is that private? It's private. I can't use it. It's private. But it's probably re-exported, right? Yeah, there we go. Yes, there we go. Thank you, Silmeth. And man. And Kamundi. As in pipes block instead of block, because you can then locally catch the mlo error. Oh, I see what you're saying. Yeah. But we'll just go with this. I like this. This flows better, I think. Yeah. So the consequence of it not being convertibles, I have to do this. I have to map the error, which is fine. Map the error to a string, and we're good. And I'm done, right? I'm gonna take a break. Why do you get a point? Because you're trying to help. I haven't been ignoring it. I've been collecting input from 4 or 5 different people at once and trying to absorb the learning. So if it looks like I'm ignoring you, it's probably because I took in feedback from you and a few other people and then selected one of those. But it's not that I'm ignoring you. I'm trying to listen to all of it. Yeah, so like you said, the question mark operator expands to a return, which is always returning. So when I was getting into that weird thing with block, I'm like, okay, yeah, I can't return out of that block. It just didn't make sense the way I was writing it. So, yeah. You thought it was funny? Yeah. It's quite a thing to stream with 4 or 5 different people trying to help you. It's like a juggling act. I'm juggling like 4 or 5 different things at once, which is why I need to take more breaks. I'm gonna take a quick 3-minute break just to get up and stretch. I'll be right back. I am 10 seconds late. Sorry. No, we're good, Kamundi. I probably need to say that I do miss messages, but you did tag me a few times, and when I saw the tag messages, I tried to incorporate what you said, but it's really hard sometimes. 1/6 of a minute. How dare I? I know. Thank you, 715209. Okay, while I was feverishly trying to learn there in that last work period, there are a few people I did not acknowledge who are here in chat. Cheesegee, hello. E-check borrows, yeah. That's like always on. You can't turn it off, can you? And Ravenous. And Moscowish, hello. Hope you guys are doing well today. I'm trying to find... Scabish was at 12:36. There. It just works, trademark. Yeah, exactly. Yep, that's what we want to try to see with Rust. Once we get it to compile, just works. Alright, so this is changing the current working directory, loading a script, setting its name. Oh, I need to fix this. I want to have equals in front of it. And then executing that chunk, mapping any errors to strings, and then if we get that far, we call the function that we're supposed to call once the script has been loaded. Then we restore the working directory and we leave. If we get this far, it's okay. Right, so the whole point of this okay is because we're returning a result because we could have a failure at this point. Basically, either loading the script or executing it, or setting its name, all of those things can fail. Load can fail, right? Load doesn't fail? Hold on. I would expect this to be a result chunk. Oh, load doesn't actually load. It's lazy. Ooh, look at that. It's lazy. So what? Exec probably does the load. I'm looking for it. I want to see the load. There's the P call. Where's the load, though? Push C function. It's somewhere in here. Maybe it's before the call. Into function? Is that what it does? Yeah, there it is. Load chunk. Which will do a load somewhere, right? Where are we looking for? Oh. I don't know there's a load buffer X. That's cool. Huh. Anyway. That could fail. So the call does two things, actually. It loads the chunk and then executes it. Right, so this is lazy. This actually loads and executes. We could also have a problem here for set name because it returns a result. Yeah, okay, got it. If you guys hear kids yelling in the background, it's my kids, and sometimes they make noise even when I'm streaming. So I should be able to run this and we should actually get errors because the test scripts are going to be trying to call back in, right? Yeah. Unable to load script, attempt to index a nil value global MoonUnit. So that's where, to fix this, I need to establish that meta table. So that's going to be the next goal. So the current task is not right. I just need to update that. Porting, so this is, we're at the point where we're attaching the test runner to the tests via meta table. There we go. My mic doesn't pick that stuff up. Sometimes it does. Tell him to go outside. Hey, everybody go outside. Just kidding. All right, I need to establish the meta table in with Lua, right? That's what the C++ did in with Lua. I think I don't need to do that, but I'm not sure. I'm going to guess that we don't need to call open libraries, but I do need to create a meta table and attach stuff to it. So I need to figure out how to do that. I didn't do that yesterday, so I'm going to have to refer back to mlua, right? So Lua, how do I create a meta table? Just create table. But how do we make it meta? What if I just look up meta? Set meta table. What does that do? Interesting. So I could make a table and then call set meta table on itself. And that would be the equivalent, right? Because in the end here, that's what this does, right? Set meta table. I don't want to dig too deeply into that. But if you call it on itself, yeah. Actually, why am I calling that? Oh, this does more than just creating a table, right? It creates a table and then puts it in the registry too. Oh, right. Do I need it to be in... I don't know if I actually need it to be in the registry or not. What do these do? These do check U data, which requires it to be in the registry. Right? Because it's going to call get meta table and has to have the same name. So I really would like to have the equivalent of that in mlua if I can find it. Meta table's all the way down. Yeah, at least 3 levels. Okay, actually, what if I just look at set... How does this work? It just works with a normal table here. AVH4, hello. Hello to you and your 2 viewers. How is your stream today? I'm trying to, right now, figure out how to connect my Rust program with my Lua interpreter. This is how I did it with C++ and Lua. We could call Lua's new meta table function, attach some stuff to that meta table, and set it as a global. I'm trying to figure out how to do the equivalent in Rust right now. Think you can create a hash table and then set a global? Yeah, but the meta table does a little bit more, right? This one also sets it in the registry. This part here. I need to make sure that this part is actually done. It also does this too as a convenience. It sets the name to be the table's name on itself. So if anything... Actually, what if I just... Can I search for that in mlua? Will I be able to find that? Hold on, let me go to the other project where we had mlua stuff, and then... Can I just search for that here? No. Well, probably I'm not going to be able to find it. My best bet is probably in the documentation here. So if again, let's just search for meta, or meta table. So they're just getting set. I guess I could just try... So the table itself doesn't need to be its own meta table, does it? Think about this. How's the Rust going? The Rust, I'm learning. So the last Rust I did before last break was to do this. So I figured out how to using and, then, and map error. There are 2 places where we could get a mlua error, and that is from set name, and the other one's from this exec. So because set name could already have us an error, the and then it'll only go into there if it's not an error. If it is, it'll end up in the map error. If exec returns an error, it'll also end up in the map error. So that allowed me to not say map error twice, once after set name and another one after exec. We can just have it in one place through the magic of and then. So learning how to use these combiners to make it both readable and also terse and, you know, not repetitive. So given a Lua interpreter, we load a script, we set its name, and if it is successful so far, we execute that chunk that we loaded. And if we couldn't set the name or we couldn't execute it, then we take that error and we convert it to a string. And then if it was an error at all, then it gets returned by that magic question mark there. It comes out as the string here in the error alternative of a result. Otherwise, we run the function, the closure that we were given. Actually, I guess it's a what's the term for that? Fn once. What's the words we're supposed to say for that? It is a closure, right? It's a closure meant to be called once. So we call that closure with the same Lua interpreter. And oh, I just noticed something. We can't do that without doing that, right? I need to do this inside of a block. This needs to be these need to be paired together always. Ooh. Can I make an inner function that does that part? I could do that with a closure, right? I would do it like this, right? It only needs it could actually just move everything in, right? So move this. Actually, and then let result equal. No, I don't even need to do that. No, I do need to do that. But I would put the OK here. And then do result. And then I have to call it here, right? Is that not how you can define and then call a closure? What's the error? Call expression requires function. If you meant to create this closure immediately, call it surround the closure with parentheses. Okay, will do. Surrounding the closure with parentheses. Okay, there. So that no matter what happens, if that returns early, I still restore the current working directory before returning the result. Perfect. I'm glad I caught that. Familiar with that kind of chaining from Elm? I know Rust adds all ownership borrowing stuff. Yeah, I'm struggling with the ownership borrowing as well, which is why I had to like where I'm using this out here. When I wanted the self to go into these closures, I had a multi-borrow problem until I decided one way to solve it is you just pass in the things that you wanted to borrow or share in, and then you're really forming a chain. So this with Lua is going to take itself and put it into that closure, right? So that it comes back out here as runner, and then again the runner with script takes the self and puts it back into the function call again here. So even though like this runner appears in multiple places, it's really just the same variable itself, right? So before I was not passing it through and just trying to do that with self. And there I was getting that, oops, we multi-borrowed self in like 3 places, right? But doing that, it's okay because it's basically forming a chain. First it goes into with Lua, and then it passes along that borrowed mutable self-reference to the inner closure, which then takes that as runner, and then again the second step calls with script on it, which again takes that mutable self and pipes it into the provide a closure again, and it goes into this inner runner where we finally are able to use it, and then it backs back out. So it's not like anything is in parallel. It's all in series. It's just you have to tunnel it through to avoid multi-borrow. And there's probably an even better way to do it, but the cost of tunneling self in that way is that this runner shows up in instead of self. I can't say self here because self is already being borrowed here. Yeah. So I'm still getting used to that. I'm not doing it the most idiomatic way in Rust, but I figure as long as it compiles and does the right thing, then step one is complete, because my order of operations is usually to make it work first, then make it right, which now includes idiomatic. And if it's not fast enough, make it fast. Although, found so far, we haven't had to do that, because Rust is pretty dang fast as long as you get it to work and it's idiomatic. All right, so with Lua, I want this to set up a meta table. What if I just start up by setting a table which will build the same way I do in C++. So I make a table, I have it point to itself through its indexer so that you can reference these as methods, and then the one method I want to make sure is there is this one. So first I would make a table, right? How do I make a table? Is it just create table? Create table. What's create table from do? Fills it from an iterator? Interesting. That we could fill from an iterator. Actually, that might be a convenient way to do it. But let's just do create table to start with. So, why is it a result? It could fail? Why would it ever fail? This doesn't... create table here never fails, right? Oh, probably because we have to call into Lua, and Lua could panic. Yeah, okay, so at all times we have to anticipate Lua might panic. Alright, so then let MoonUnit equal lua.create table unwrap, because we're just going to panic if it fails. What's on nightly? Try block? But a whole thing I liked about Rust was that you didn't have to do try catch stuff. But thank you, Simsy. I'll have to check that out later. It's a proposal, eh? In nightly? I keep hitting the wrong button. Hit enter and then paste. There we go. Alright, so then I want to attach a function here. So MoonUnit dot set test equal to lua.create function. What's the difference between create function, mute? A mutable closure or an immutable closure? We don't need to mutate our environment, so just create mutable function. And the function gets what? It gets the Lua interpreter, and it gets an A, where an A is its arguments. Okay, so this is highly generic. So I have to specify the type. Well, it'll be implied by what I give to the closure. So here it would just be Lua, and oh, how am I going to have the callback reach back into ourself? Oh, this is going to be a problem, isn't it? Because in C++ I was able to cheat. This recovered itself through a raw pointer. I can't do that as easily here. Unless there's a way to tunnel things with UDatas, and even then, aren't I going to have a problem with reference counting? Yeah, I gotta fix this. I gotta work. I need to find a workaround for that. Creating a result returning function which is immediately called. I haven't found that useful though. Well, I did it because I wanted to bracket the call with making sure we restore the current working directory. I guess another way to do it would be to make an object whose destructor restores the current working directory. Then I wouldn't need to do this junk with putting into a closure, right? Just to capture the early return. Maybe it'd be more idiomatic to make a structure which restores the old original current working directory after setting it once. Then with RAII, if we return here or here, doesn't matter. It would always do that. Yeah, we're not gonna do unsafe. And that was me hitting the wrong key there, by the way. I don't want to do any unsafe code. I want to find out, is there a way to make UData with mlua user data? There is. How do we do that? Oh, that's cool. I would implement the trait and it would be eligible for use inside of Lua code. Cool. So I can move the tool state that needs to be accessible from Lua into another structure that implements this trait then. Right? And then I would get that I'm assuming I would be able to add a method and get it back out. Yeah, through this. There we go. That's what I want. By implementing add methods. Cool. That's what I want. Let's try that out. That means I need something separate from runner. The path nonsense is in my way. Let's move that out. Okay, so there's runner. Let's make a struct MoonUnit, because that's what it's called from Lua. And we're going to say that it derives... No, it's not derive, right? It's just that it implements. Impl mlua user data for MoonUnit. Okay, and what do we need to implement for that to work? Nothing is required. If I implement and add methods, then I can add my methods. So it's fn add methods. Oh, look at that. It filled it in for me. Isn't that cool? So then we'll do, we're going to use methods. Methods dot, what? Add method? It's not helping. It's not helping. Dot. Probably because this is out of scope. mlua : There we go. Methods dot add method. There's also add meta method. The name is test. The method. Biting my keyboard right now. I don't like this. Method. It wants a closure, right? A closure that's given a few things. Refer to user data methods. Okay, it's given the Lua interpreter. It's given itself. Right? Add a method that accepts T. What's T? I see S, A, R, and M, but I don't see a T. Is that the associated type or something? I don't like how this is written. Maybe send? Maybe. Maybe not. Let's just go back to the example here. So this must be the Lua interpreter. That's us. And this is the arguments we're given, and we need to be explicit because there's no other way to infer it, right? And we return a result with whatever we want, I guess. Yeah. Right. Okay, so the result is implied. So our method... how best to do this? How about like this? Probably don't need the Lua interpreter. We need this, and we need to specify our output, our input. What would our input be? Can I destructure here? Or do I destructure like this? I can't remember how you destructure here. Let's just keep it like this. That is going to be what? It's going to be something. All right, and then let's just say okay for now. That all compiles, right? We have an error down here because I didn't finish this. Right, so instead of doing this, I really want to instantiate one of these with the interpreter. How do we do that? Oh, we do set. Exactly. Okay, so that's what I'm going to do down here. Let MoonUnit equal MoonUnit new. Do I have to make a new? I guess I do. Or I'll just be just do that for now. And then Lua dot globals dot set MoonUnit to MoonUnit. And unwrap that. Then it should be able to access this method, and let's just have it print something. You called me. And let's see what that does, because I like experiments. Yay, it worked. So if we want to see what arguments are passed, I need to be specific here. So technically we're not using this yet. Might as well call it what it is. It's Lua there. My arguments are what? Depends on what the script is given. Suite name, test name function. So it's suite. Can I say it's a slice? I don't know. Test is a slice and well, it's name and then test really. Suite name test, which is I'm guessing we're going to consume it, so it's mlua function. Okay, what's wrong here? Oh, we can't give them names. All right. I just do that then, right? And what's wrong with this? The following annotations were found. BCA. The trait bound is not satisfied. I don't understand this. The trait bound is not satisfied. What's it trying to tell me? Cargo Clippy. The trait from Lua multi is not implemented for slice. Okay, I think what it's trying to tell me is it doesn't know what to do with slices. What if I make them strings? Then we're okay. All right, cool. So then you called me with these arguments. Let's go ahead and print them in debug. Args. There we go. Look at that. I got all my test suites and tests, and we got functions and everything. That's cool. Okay. progress. So I think I want to just then go back to the porting. What was I doing here with the to-do list? I didn't say, that was just a mistype. Okay, so the runner. So basically all this code goes away and it gets replaced by this then, which is cool. I actually like this a lot better than the way I used to do it like this. So Lua test, before it just stashed the function somewhere and then we would get it back, right? Let me see how we did that. So load test suite would, this would stash it, so then we would get it back somewhere here. Oh no, the find test. No, find test, it's gonna stash it. No. The script would stash it and find test recovers them from the registry here. Right, and so what it does with them is it puts it into the test suite. Okay, so that means I need to hold on to the... If I hold on to the Lua functions, then I need to hold on to the MoonUnit object, right? Because they have the same... I'm going to have lifetime issues if I don't. But for now, let's not hold on to the functions. Let's just take the test names and the suites. So I have test suites. I'm not using them though. Let's use them. I want to put this back into... do I want to put them in a MoonUnit and have a runner hold on to the MoonUnit? Thank you for that follow. Let me think about this. This I already... Oh wait, there's one more thing here. There was one part of this I haven't done yet, right? No, I did all this. This is all done. That's all done. What was it that I was missing here? Find test wasn't needed, right? Right, I didn't actually need to call this ever. I probably don't need that. I'll leave it there blank for now. What was it that was not quite... Was it with Lua? Oh, right. The, with script, this name, it needed to have an equal sign in front of it. Shoot. Because, like, if I have a bug in this, like, if I don't end that correctly, and I run this, it should have not parsed. Yeah. And it doesn't have the correct thing in here. Actually, it does have the correct thing in there. Oh, right. That's if it's a syntax error. If it's a runtime error, I need to make a runtime error here somewhere. Let's just say X there. Make it a runtime error. Then, yeah, see, it says string that. And I want it to be a file name. Actually, it is a file name. But the string is too long. Okay, that was a problem with the C++ one anyway, right? Oh, no, it's because I didn't put equals in front of that it says string that. Okay, so that's the problem. I need to put equal sign in front of here. I really want to grab this separately, right? Can I say, like, let name equal... What I really like to do is say equals plus that, or concatenated with. ToString, is there a concatenate? There's no concatenate. That's what bugs me. Shouldn't string have like a concatenate, or can I do a plus on this once it's a string? I can if I do that, right? No. to string. Yeah, you can't add strings together. Wait, what? Oh, can I if I do that? Oh, there we go. No, it's still got a problem. Semicolon. There, what? How come it says it's unknown type though? Shouldn't it say it's a string? Why does it say it's unknown? You can, if you remove the toString on the left side. I think for plus to mean something, it has to know it's a string, right? What if I just say it's a string? Whoops. Whoops, whoops, whoops. Yeah, I think if I drop that, it has a problem with it. Doesn't know what the plus means. Cannot add a string to a slice. But if I convert it to a string first, then it does, it concatenates them. Not being able to add. Yeah, but Kamandi, I don't want to ignore you. It's just weird that I have... Okay, there's got to be an easier way for me to concatenate. I'll figure that out later. The adds bytes works, right? That gives me a slice of bytes. Okay, let me see what I get with that. Yeah, okay, so that works. The .lua is chopped off, though. Oh, wait. It got chopped off arbitrarily at that point. I think it's just because it's too long. Just to make sure, let me do a debug. See what name we actually set. Oh, that's going to be too long. How about we debug the name and then do add bytes? As bytes. There we go. Yeah, so it's getting the full names of those full path names. So it says the whole path name here. But for some reason it truncates it to that many characters. I think I want to get rid of this to un-UNC it somehow. I need to figure out how to do that. Maybe there's something in Rust to remove the UNC-ness from it. Rust, Windows, UNC path to normal path. I don't know what to call it. What's this one talking about? Yeah, that just gives me a UNC path, right? Canonicalize adds the extended length prefix to the path. I wonder if we could just chop that off always. We always know it's 4 characters, right? And I already have a fixed silly strings thing. What if I just chop it off? Can I just like, can I say like dot, or can I just like make a slice out of this? Can I say 4 dot dot? Huh. I can. Actually, I think it needs to be 3, right? No, that's not working. So that doesn't actually do what I think it does, right? No, it does. Wait. One, two, three. How many characters are in that then? Should it be 1, 2, 3, 4 characters, right? So shouldn't it be 4 dot dot? But it's saying if I do that, it doesn't exist. Let's do debug. Oh. Yeah, that's not gonna work. What's 0 do? Okay, scroll, 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 scroll. Scroll. Oh, it only did one piece of it. Okay, I did it in the wrong place. Yeah. So, that won't work. Because I do the fixed silly path delimiter nonsense with the line, not the whole path. If I moved it, though, to outside here, that would work. So, wait. It's after we join, and I need to do it. Yeah, I'm doing it. Well, I'm doing it to the suffix is what I'm doing, Kamandi. I'm only working with paths because I don't like to see this thing in front. I just don't like seeing it. I don't know. Maybe just leave it alone. I'll leave it alone for now. We'll just leave it alone. So, as long as it has the right, it has as much of the path as we can put in here. I can't help with Lua chopping the name off early though. So I'm just gonna drop it. I'm just gonna move on. Okay, so then the dunce crate, yeah. I'm dropping it for now. When I get back to it, I'll consider all those options, including the dunce trait. Really, I just want to make sure that was doing the right thing. That puts an equal sign in front. If only I could do it without making a new copy, that would be cool. But I don't think I know how. I don't think we can do that. This needs to consume something, right? Actually, it has to be all in one array. That's the problem. So I have to lay out in memory an equal sign followed by the path anyway. So I need to end up doing a copy is needed anyway. Either way. All right. So then let me move back to what I was going to do next. So let me repair that script that I broke on purpose. Make sure this is okay. It's not running because I messed this up. There. Okay, so there's a debug in there somewhere we don't need. This one. Cool. All right. I was gonna store all of the test suites and their tests next. So that is in... Not in with script, not in with Lua, but in... in the function that... In this function right here. So... If I could somehow figure out how to destructure that, that would be really cool. Can I destructure it this way? Can I say name, well, suite name function or test? Can I do that? Because that would be sweet. Then I could say you called me with, well, sweet. What do we want to say here? Let's just say sweet colon test. Sweet name, and then we won't use test. If this works, that would be sweet. Oh yeah, look at that. That works. I can destructure that. How do I make this easier to read? Maybe put these on different lines? And then these could be on different lines. Like that. Just to make it easier to see that here are our arguments, and I'm doing it by destructuring a tuple. Okay, now what I want to do is this needs to have access to wherever I decide to put the test suites. Why do I have that? Where do I use that? Oh. That was just to satisfy this requirement for get test suites. What does get test suites actually do in the real one? Yeah, okay, so from the runner we need to get to the test suites, but we also need to get to the test suites from the MoonUnit structure. So that means I probably want the MoonUnit structure to be reference counted to share between the closure that we're using with down here. Where is it? Right, when we're borrowing self, actually, we get the runner all the way down in here. So I could pass along, let me think about this. The problem is that when we get to this method here, we're only given the interpreter and our self and our arguments. None of these get us access back to the runner. Actually, but that's okay. This is what? Immutable reference? I can't make it mutable? It's an immutable reference. Oh, but I can make it mutable. There we go. There we go. So now this is a mutable reference to MoonUnit. That's what I want. Then I've just put the test suites in here. So how do I call it in the C++? I call it test suites. Test suites. Test suites is a test suites. Okay, that means I'll probably want a new, so this should just call new, which we don't have yet, but we'll add it. So impl MoonUnit function new returns a self because it's a factory. Self test suites is a test suites new. Got it. All right. So then here I could say we insert it if it's not already there, right? This is find test does this right now in the C++. Right. This is index it, inserted it if it's not there. Now the equivalent of that, if I remember right, is this dot test suites dot entry. And the key is suite, and then dot or insert, or no, or default, and then that is our suite. Cool. Except for or default didn't work because we don't have a default for a test suite. I can make a default test suite, right? Doesn't satisfy runner test suite standard default. No method or default found because, yeah, the test suite doesn't have a default. I can do that though, right? I can say derive default. There we go. Making use of entry, yes. Non-static lifetime that doesn't have a single character name. Yeah, well that's not even mine. That's the developers of MLua did that. Yeah. Croco Doctopus, how are you doing today, by the way? And AJ Potato 214. Looking to start a coding stream, what's the best strat used for hiding secrets, tokens from viewers? Have a second monitor. Make sure that all of your programs by default start on the hidden monitor, not the one that everyone sees. And if you're writing code that is dealing with tokens, put in special code to hide the tokens when they print out to log files. So, like, where did I do this? In my Twitch library? In the Golem? Golem.cpp, I think. No, it was deeper. It was in the Twitch library, I think. That would be called message. Would it be called Twitch? That's not exactly right. It's message or something. Yeah. Token or OAuth or something. Maybe it wasn't in this one. Where are we? Messaging. Yeah, so do something like this. If you're ever going to work with stuff that you don't want shown on stream, make sure you write code that does this so that when you're showing your log files on stream, it doesn't actually show your real OAuth token, but replace it with an arbitrary number of stars. Yeah, do stuff like that. Keep the files that hold your secret keys and stuff in a completely separate directory tree so that you don't accidentally open them, nothing like that. That's what I recommend. But then, AJ Potato, you're going to leak a key at some point. So, in addition to making it hard for yourself to accidentally show keys, have a procedure in place so that you can quickly revoke a key. So before you even start working with like OAuth tokens, for example, practice revoking an OAuth token really fast. Like have even if it's like maybe a script you have set aside that you can quickly switch to and run it to revoke your token. Yeah, a panic button. Yeah, have a panic button for, so you don't have to shut the whole stream down, but at least you can quickly revoke the token so that you limit the damage. So that's what I would say. And hello, Makings of a Hero. How are you doing today? Yeah, those are the things I'd recommend. Limit the chance of exposing something, but expect that it'll happen and have a panic button of sorts. So, Makings of a Hero, I'm doing Rust stuff today, and this is a Rust program that is using Lua. So we are making, we're using the mLua library in Rust to define our own foreign function interface or adapter between Rust and Lua. That is, in my case here, this program is supposed to hook up for unit tests. So when a Lua unit test like this calls this hook, it will end up here, and what we wanted to do is remember that this is the function to call to run this test for this test suite. And then that I already have this in C++ and I'm porting it to Rust. Already I'm happier because this is a lot easier to look at than the equivalent in Rust, which is this garbage, along with the create meta table. This junk right here. This is just awful. And the fact that when the Lua calls it, it actually stashes it in the registry, and then we have to do this find test to grab it back out to put it into the... Yeah, it's crazy. Ski Dog, 12 months in a row. That's an entire year. PogChamp, how are you doing, Ski Dog? I'm just going over some of what I'm doing because we got a raid from Makings of a Hero. I am porting a C++ program which pretends to be Google Test, so that in my unit test suites we have not only C++ tests like this, for example, but we also have Lua unit tests. That's right. It's two different languages. I have a program called MoonUnit that impersonates Google Test and so fits into the VS Code plugins I use, so that the plugin thinks it's a Google test when it's really a Lua test. And the magic is in making the output of the program look like Google test. And then when the plugin tells the tool, the runner, to run can afford test out of this test suite, that we need to recover the Lua function and call it, and then have some way for the test, the code in the test to check expectations, right? These are the asserts. So if this variable is false, then this call will mark the test as failed, so that, you know, when I run it, it's a pass, but if I change something and run it again, it's a fail because we have a mismatched expectation down here, right? So it's all about the porting because I already have the tool that works, and I'm going from C++, which is really ugly mess, to Rust, which is a lot cleaner, arguably. And I'm doing well. I'm always happy when I get stuff done in Rust because I'm still learning it, and you can do some crazy things in Rust. Look at this. This is destructuring a tuple, which is given to a closure, which we registered with the mlua library to be called if something in Lua accesses a method of a user data table. So it's like friggin' like 8 to 10 different things at once that we're doing. It all fits into 20 lines of code. It's like magic. Yeah, there's a lot of like flavor of JavaScript here because this kind of destructuring, like I didn't really see until I learned JavaScript, the modern JavaScript, but it's really cool. It's basically saying this is the type that we expect, and so this string, name it sweet, name this string name, and name this function test. And there are all those subtleties in here, like if in Rust you don't use something, it will give you a warning saying, hey, you're not using that. Let me comment that out so it doesn't get in our way. See how it puts a yellow squiggly? It says, you're not using that. But if you put an underscore, it's like, nah, man, we're cool. We're not going to use it. Sure. Seen that kind of destructuring in Ruby too? Yeah. There are other things I've seen in Rust that make me believe strongly that the designers of Rust kind of borrowed from all sorts of different languages. They like said, "Oh, this is cool from Scala, and this thing in Ruby is cool. Let's pull them all the good things." So I'm at the point of porting this code where I want to take the list of, we have the list of test suites and the tests they contain, and I want to store them into a hash map so that we can select which tests we're going to run and report. So what I want to do here, I was printing, right, so it's not going to be called suite anymore because we're shadowing suite by making something new called suite, which is their entry. So I can't print this anymore. That's okay, we don't need to print it. This makes sure that we add an entry for the test suite. And if it didn't exist, we fill it with the default, which is an empty table of tests. Then with that suite, I want to go to the, well, we're going to mutate it, right? So I have to say it's mutable. This is what another thing that's different about Rust. It's like the opposite of C++. In C++, if you just said, like, make a new variable called suite and assign it to something, you'd be able to, like, reassign it later. But if you only wanted to set it once, you would say something like const auto suite equals something, right? In Rust, it's the reverse. If you don't say anything, it is const. And if you don't want const, you have to say it's mutable. So that says assign something to suite, but then let us change it. So the way I want to change it is going into the tests and, again, make an entry for the name or make a default. And in order for that to work, the test itself has to be defaultable, which, through the magic of Rust-derived traits, we can accomplish with one line of magic code. Those things mostly come from OCaml traits. See, there you go. See? We grab things from Ruby, OCaml, Scala, C++, C#. We don't pick, and we're not stingy. We'll pick from every language. Haskell, Ruby. In general, Rust borrows a lot of features from other languages instead of innovate, so it feels, well, but maybe you can say their innovation is in mixing together what's great from a whole lot of other languages and making it actually work together. Hey, if they reinvent the wheel, they're good in my book. I like to reinvent wheels. By the way, we have a lot of these yellow lines simply because I told Rust to be a nanny and be pedantic about its warnings. There's even a level called the nursery, which apparently is even more pedantic than pedantic, but it's not stable yet. You're a JS Python guy, always happy to see the best of other languages. Yeah. So again, my favorite things about Rust That's actually under like. Why I like Rust? Number one, it's because it's challenging to learn. I like difficult puzzles. The challenge of learning Rust is a difficult puzzle, so it's good in my book. But what I really like about Rust, jokes aside maybe about that, is that it's hard to get to work, but once you get stuff to compile, it usually works right out of the box. And the pain of making stuff work in Rust, it's the language and its libraries and how they're designed to kind of guide you to make good designs. And I really like that. So even though it's tough, it's a really steep learning cliff. Once I've been able to get stuff to compile and link, they generally just work. And they're actually not too bad to read. As long as you get through the syntax, the markup, so to speak, like the mutts and the cows and the other animals I have yet to encounter. But yeah, once you kind of get this under your belt, you can read it a little bit easier. Like this is saying, this is a function which it's public, so we can call it from other modules. This is the name of it. It's generic. You might recognize generics. So the type varies along two dimensions, these two different types, which are constrained to be E has to implement this trait, and this trait happens to be a closure which is allowed to change its capture state. And it is, when you call the closure, the Lambda expression, the function object, whatever you want to call it, you're going to be passing it a reference to a slice of a string that you're not allowed to change. So there's just a lot of words that go into these four characters, for example, right? And our other dimension of generic here, this P, is that the file path has to be something we can turn into a reference to a file path. So what this is doing is it's saying, please load the contents of this file and read it in, and then interpret it with a Lua interpreter. And if all that goes well, then we're going to store that test suite in our database. Otherwise, we're going to call the error delegate. We call it at different places to print different nice to see error messages. This is not idiomatic Rust, by the way. This is just a direct port from the C++. Idiomatic Rust, my understanding is that instead of returning nothing, we would probably return a result, and the result would encapsulate the error messages. But I haven't done that yet. Hey there, Juicebox Hero. How are you doing today? All right, so let me get back to what I was doing. Right, the storage of the information about the tests. I think all I really wanted to know was that we have a test like that, and I want to move this print somewhere else. I know what I wanted to do. We're storing this here in MoonUnit. MoonUnit needs to be accessible from the runner, and I don't have that yet. Instead, I had this placeholder. So really what I wanted to do here was have the MoonUnit. MoonUnit. I guess it really ought to have an underscore there. And then that means our runner needs to have a new somewhere where we set up a MoonUnit. So that would be here. MoonUnit is a MoonUnit new. All right. And then instead of cloning some old thing, what we're going to do is equivalent of what I had in the C++, actually. Get test suites is supposed to just iterate through the suites and return us the keys. So I think I can just do that with self.mooununit.testsuites.keys.iter. No, we need to clone them, right? Clone into? No, clone into iter, I think, is what we want. All right, and this is almost right, except for this is wrong. Curious about Rust and why everyone both likes Rust and makes fun of people who like Rust. I think there are two things going on with that. Why do people like Rust? And then two is What's with the teasing slash dogma slash superiority? So I think why people like Rust, it could be for the reason I like Rust. Like Rust. It's challenging to learn, but once you learn it, it tends to force you to make good designs, and most of the time, once you get stuff to compile, it just works, because a lot of your effort is going into fixing your bugs really early. Here's the order of my preference in how to when to catch a bug. Before you even write it is perfect. It sucks if you don't know about the bug until your boss calls you up Saturday morning to say that something blew up. So what I found in my experience with C++, I catch most of my bugs in the unit tests, and if I don't catch it there, I usually catch them when I test them manually, or if I have integration tests, right? So it's, it's somewhat acceptable, and that the boss never yelled at me for blowing anything up, but it would be cool if I could catch them earlier. What I'm finding with learning Rust is that I'm finding a lot of my bugs either during compilation or before I even write it, because as I'm writing it, the plugins to the editor are telling me that I have problems already. Whereas if I had written the same thing in C++, the compiler would be like, okay, whatever. But then kind of blow up when we get to step 4. So it could be that people like it because of the same reasons I like it. Or it could be that it's more modern and doesn't have a lot of the crud that old languages have. So the syntax, there's a bit of grace here. Once you get past the somewhat esoteric notation, then there's a certain grace to this, a certain mathematical, functional style to it. So those are maybe 2 reasons why people like Rust. Now, what's separate is the teasing, the dogma, the superiority. I think what that comes down to is that there are a lot of people that get so into Rust that they start to see the world as being those who use Rust and those who don't yet use Rust. And they get a bit overzealous in that. So what I like to do is separate the 2. There's the good things about Rust, and then there are, unfortunately, those who like to kind of impose their dogma on others and say, if you're not using Rust, then what the heck are you doing? Rust is the best. I'm like, okay, you guys have fun over there. I'm just going to take what's good out of Rust. So yeah, there are some opinionated things in the language, but I'm finding that it's more of just getting used to the culture. So every language has its own culture, right? I like to call it the things I don't particularly like about Rust. Or is it not my favorite things? Right. So I have this list of things that are not my favorite things. I don't want to say I hate them about Rust. I don't want to say that they're wrong, because they're just things that, they're like culture shock, right? You go to a new country, they have different ways of doing things. So in Rust, they like snake case for functions and variables, okay? They like camel case, but not snake case for traits. Okay, so you just get used to these cultural differences, right? There's a little bit of preoccupation with how long integers are, okay? I've seen that kind of thing before. We can get over that. So I'm used to, in C++, using int. I don't use int in Rust because there's no such thing. You have to either pick a size, or you say it's the size, which is like the size t of C++. So I got over that too. This one, where sometimes to use an extension available through a trait, you have to pull it in with a use statement. And there's workarounds for that. I'm getting over that because for me as a casual reader, it wasn't obvious because I'm not used to it yet, but I'm getting over that. Terseness of terms, I think it's kind of, it was kind of a shock at first. I didn't know what a mut was or what an RC was, but you get used to that too. This one is still a sticky point for me. I really don't like that a slice starts with str and is lowercase, and a string where it is dynamic and mutable and all that stuff is capital string. It makes me think, does that mean that there's another type called an ing somewhere, and that a stir is like a string which has been cut in half? I don't know. They ought to just have named it something like slice or string slice or something. But it goes back to the terseness, right? So you can get the idea. There are just things that are cultural differences in Rust that you get over, that someone who maybe takes this opinionated set of cultural Rust
qualities and kind of tries to impose it on others, so you could be seen as a burden to others. A slice is, let's see if I can do this in text. So a string is basically a pointer to some memory on the heap containing text. And along with that pointer is also a length. So how many characters there are. And I believe, I might be confusing string with vector, but in general, like this kind of thing, you might also have a capacity. So how much memory we allocated, including what's not being used. Okay, so then what a slice or a reference to a string is, it is a pointer to some memory, might be on the heap, might be on the stack, who knows. And we have how long it is, or length. So there, you can see there are similarities here, and it's easy to go from a string to a slice because you basically pick what subset of this memory on the heap and just set the slice pointer to that, and then adjust the length to be the length minus however many you excluded. You lose the capacity here because this is fundamentally immutable. And this might be mutable. Might be mighty, might be mutable. So roughly the this is the equivalent of, in C++, it would be a const char star with a length. All right? In a string, the equivalent in C++ would, I think, would be a standard string. So not only do we have some memory, we know it's on the heap, we know how long it is, how much we allocated, and we can change it. Whereas a slice, all we really know is, hey, there's a string there, it's this long. We don't know if we can change it, so we're just not going to even allow you to do it. So you can take a string and slice it, and then you can continue to slice it into smaller pieces. So a string might have hello in it. Let x equal hello. But then your slice might be let xs for x slice be from characters 1 to 3, and then that would give you el, right? This gives you the whole string as a string, and this is a slice. Does that kind of make sense? So with this, you could further slice it and say let, that should have been a let, not a lay. Let xss equal xs 0 to 1, then you'd get just the e. Right? I think that's why it's called a slice, because you can, just like in a Python, you can slice up an array. You can get a subset of contiguous elements out, and it works not just for strings, but also you can do the same kind of slicing operation on an array of any other kind of primitive type. Yeah, no problem. I like to explain these things. The stream team I'm in, one of our goals is to like Coders Dev, one of our goals is to be enthusiastic about technology and to explain coding. So as I'm working, people have questions. I like to delve into those questions, even if it's a sidetrack, because not only do people want to know the answers, it's also interesting sometimes to know how, oh, you're in the Live Coders too. I didn't know that. We have so many people in our team. So check out Juicebox Hero. Yeah, so try to live up to the motto and the creed or whatever of the Live Coders. Try to explain these things. Close to like 200 now. Yeah, we have so many people in the team now that we're the new people are coming in as interns, as in we're mentoring them to get more viewers, get more into it, that kind of thing. You're also a resident Twitch staffer now. I can see that with the wrench. Nice. Yeah, get some coffee. Anyway, did I miss any of the chat? Is it not entirely correct? You can have a mutable string too. Oh, Silmith. See, Silmith is like the expert at Rust, and I'm the Padawan. So yeah, so this is maybe one kind of slice. So we could let's say the immutable kind. The immutable kind. So we're not going to go into Jedi tricks like the mutable slice, because that scares me. Typically, when you see introductory Rust material, slices are going to be immutable. But Silmith's probably right that you could have a mutable form of a string slice that I'm not going to cover because I'm frankly really terrified of it. Let me save this as a stream note. I've been getting to the habit of doing this recently where I write stuff down like that, and if I get asked again, I'm just going to want to recover what I already wrote, right? So why not make a bunch of stream notes? And I've been collecting them. So this is going to be Rust, strings, and slices text. We can get back to that if we need it again. This is too short. I'll toss that one. All right. Close that. Okay, I ran into this problem just now, and I wanted to understand what I did wrong here. Oh, expected a reference, found a structure. Where did it expect a reference? Difference is just that string owns the data and might resize it. Slice just borrows it, but it can be mutable as any other mutable reference. Yeah, for me, what terrifies me is I don't know what that means, what that implies for a slice, as in can you change its length, or can you just change the characters in that are pointed to by the slice? Probably it's the latter, right? That you can change the characters in the slice, but you can't redefine the slice for like what its length is. Mutable byte slices are common as in a buffer. Okay, so it is. So if it's like a buffer to write to, then you're allowed to change the contents, but not the length or the pointer. Is that the gist of it? So one thing you notice about certain programming groups is that they do language shaming. Yeah, so that's a thing. In fact, the Primogen likes to make fun of it with the Primogen Rust. He's got a whole character called Rustin, right? The Rustin character, which, if you ask him about it, it's about that, you know, unfortunate sub-community within Rust where they're just too zealous about it and will kind of look down and belittle those who aren't doing Rust. So, we could live with that, but just not take it in and be one of those, right? Just pick all the good things about Rust, notice all the things that require some cultural shift, and use it whenever it's appropriate. Every community has those zealots, but what I've seen is in the Rust community, it seems to be more than usual, but this is all just subjective. And I think he had some personal experience where he got kind of roasted by someone in that sub-community. Hold ourselves to a higher standard. To avoid heap allocating while streaming, you would read or pass a mutable slice, checking how much was read. Yeah, that makes sense. All right. So let me try to figure out this error. As in all things Rust, if we're not getting enough information, we can ask Clippy for help. Expected reference found struct string. Oh, I see it. It's in the item, right? This is probably giving me slices, right? Keys is probably giving me slices. Is it going to tell me what it is? It's not going to tell me what it is it? Can I see let x equal? Let's see what it is. X, what is x? You tell me, compiler. It's keys of string and test. I bet the way that the I bet that type there, if I went and looked at it, its item is different, probably, right? So if I look at how iterator is implemented for keys, it's probably easier to just look at it in the documentation, right? So keys. Where would I go? Probably should search here. Keys. Here, right? Yeah, this guy. And then I can look at how into iterator is implemented, or iterator. Oh, 100 bits. Thank you, H8 Potato. I'm very happy that you gave me those bits. It supports the stream. Thank you very much. Hope you're enjoying the stream. Yep, there it is. It is a reference of lifetime, the same lifetime. Well, there's a lifetime associated with the keys, and it's a reference to whatever. Okay, so I need to be conscious about the order of those. It's the reference to a key then, right? So it's going to be a reference to a string, but the problem is I said it would be where the item is a string, but I needed to fit that. Oh, there's a way to do a map, isn't there? I can do, hold on. So, breaking this apart, get the keys, clone them, make it into an iterator, and then, can I just map? I want the item to be a string though, but not a string reference. How do I do this? Cloned instead of clone? Now we're talking some magic. I don't know what that actually does. Creates an iterator which clones all of its elements. Oh, okay. So I don't need an into iterator? So that is exactly what I want then. Only it didn't work with keys for some reason. What's the error? This returned values to static lifetime. Oh, I need to attach a lifetime to it? Based off of what? The lifetime of self? So something like this, where I say self and these have the same lifetime? Or do I need to say here? What's this? Mr. Balrog? 3 months? Why do cows wear a bell? Because their horns don't work. It's a great dad joke. Clone is just map X to X clone. Yeah, okay. So look, I made it happy by annotating the lifetime. I feel like a lifetime master, but really I'm a lifetime novice. I think what I just did is I said that the iterator we're returning can't live any longer than self. Which makes sense because why? Actually, that shouldn't be a requirement because we are cloning it. Why would it matter? What if I made it implicitly different lifetime? It has to do with this keys somehow. It thinks I'm borrowing them or something. Can I infer an appropriate lifetime for auto-ref due to conflicting requirements? Interesting. It's lazy cloning? Oh, okay. All right. Do we want lazy cloning? What if I didn't want it to be lazy cloned? What if I wanted it to do it now? Would I have to collect it? Okay, so let me test this theory. In fact, I want to explicitly make something new with an independent lifetime. So I want that to work. But to make it work, I'm going to need to, so instead of cloning, what we can do is we can collect it and then turn it into an iterator, right? We can turn it from a lazy iterator to a non-lazy iterator. We can motivate that iterator to get up and exercise. So collect into a vector of somethings, strings. Collect it and then into iterator. How does this work? I don't have my syntax correct here, do I? Oh, I know why. This goes on the other side and there's too many parentheses. Okay, something else is wrong. Probably because I didn't turn it into an iterator. Okay, now this is a problem. Oh, I need to do the map again, don't I? I need to, oh, I can just do cloned, right? Cloned. Because that'll just move them into the vector, and then this will move them back out. Yay! Yeah, I'm trying to avoid the lifetime. I'm trying to make sure that this iterator has an independent lifetime from the borrowed self. So, if I didn't need this to have an independent lifetime, I can go back to what I had before, where I tie the two lifetimes together. I say that the iterator you get back is constrained by the same lifetime as the self, and then I don't need to do that. I could do that without hacking up my code here by doing this. And then that works too. It's just that it's constrained. Which way is better? This is probably better. Like, if the caller wanted to make it independent, they would just collect and turn it into an iterator themselves. So maybe that's what I'll do. And then I don't need this X, and I don't need that, and we're done. You can avoid the lifetime using underscore. Well, but I still have to say the plus some lifetime, right? You're saying that I can say figure it out from that, right? See, this is why you guys are better at Rust than I am. Do I like that better? This kind of looks funny to me. I think I'd rather make it explicit. In fact, I might even want this name to be self. For me as a learner. Oh, I can't use that keyword. Okay, so I'm going to say, instead of self, I'm going to say runner or something. Because this is a method of the runner. So basically this, when I read this, it reinforces the fact that this iterator lives as long as the runner does. What's happening? Multi-cursors. You'd rather read the implied names? I'm not comfortable with it yet. How could I make a compromise? Well, either have to be explicit or not. I think I'd rather be explicit right now. There's a page on it in the docs. The anonymous lifetime. Let me give you a point. And let me copy your link so I could study that later. The anonymous lifetime. For now, this should be sufficient for me to list the test suites. So let me make sure I'm actually doing that. I'm not. Did the main do this? Yes, it did. It printed them out. So we should see this now, if I did this right. Oh, wait a minute. I know it's not going to work. Because when we actually had the runner run, it made its own MoonUnit internally and not use the one from the runner. I need to fix that. Yeah, here it was. I can't do that. I have to use self MoonUnit. And this is where I might get into trouble. Because it's going to make me move it out. Can this use a reference? No, it needs to own it. Okay, so I think I'm going to have to use reference counting then. We're going to have to do it, chat. We're going to have to make that reference counted because I need to give it to Lua, but I need to hold on to a reference to it as well so that when Lua is done, we can get it back. So I'm going to use a reference counted pointer. Yeah, it's called lifetime elision. Those words in my head make sense, but I need to study it. All references have a lifetime. If you don't specify, it's the anonymous lifetime, which every scope has. So by putting the underscore there, it says figure out a lifetime that works, and the only one that works there is to have the same lifetime as the runner, right? It makes sense to me. It's just that I need to study it more so that I can reach that conclusion from the error message and not from knowing the answer already. Does that make sense? Doesn't say figure it out. It's a specific lifetime? Okay, so then obviously I need to study more because I haven't yet internalized the fact that underscore has a specific lifetime and it's not figure it out. Because in other contexts, it's telling the compiler, you figure out what goes here. Yeah, I just need to study more. That's the conclusion. Okay. So instead of holding on to a MoonUnit as a part of its composition, we are now going to have a reference to it. We still make a new one somewhere down here. Well, just search for new. Right? Only it is standard RCRC. New. There we go. Okay, and then where we need to pass it in, now I am going to do a clone into, right? No, not clone into. Clone, is it just clone? And then just give him the reference? Clone, and then I need to unwrap it or something, right? They don't want a reference count. They want... So it's like take or something, right? Take? No. As ref? No. How do I get it the value when the value right now is inside of an RC? Maybe I can't. But wait a minute. Shouldn't it just accept that type? Oh, I know what I have to do. I need to implement this trade user data in terms of the reference. Can I do that? Can I say this? I don't know if I can do that. I don't think I can't do that. I have to give Lua a value. I can't give it an RC. So I think I have to have a value which holds on to the reference to the other guy, right? So let's make one. And it will implement the user data for me. So let's call it MoonUnit holder. And implement that in terms of that. And then this one will have a MoonUnit, which is a standard RC to a MoonUnit. All right, and then we have to implement new. Well, I don't really have to implement new, do I? It's so tiny. All right, so given this, I need to borrow MoonUnit. Well, actually, let's say let this equal this dot MoonUnit dot asref? Does that work? Yes. And then I can reach in there. Actually, how is it letting me do that? It's probably because I have another compiler error. I think I have to do as mute, don't I? Or wait a minute, wait a minute. That doesn't let me do interior mutability, does it? I think I have to use a RC around a ref cell to do this, right? When you clone it, I should do RC clone. Oh, right, I read that. I keep forgetting that, Silenzy. You're right, though. So how do I say this? Hold on a second. My throat's getting dry. I would say MoonUnit handle. Is that what I called it? I already forgot what I called it. Holder. I called it holder. Where MoonUnit is that standard RC clone. This is too long now, so I'm going to break it down. Comma, and then that unwrap, and then no clone here. Whoops, the wrong key. And it's not letting me do this because I need to borrow a reference. There we go. Hey there, Nui. Good almost midnight to you as well. How are you doing today? Okay, so that's good, but now we're down to here, this problem, right? Right, so I need a mutable reference. I don't think I can... Is it as mute? No, this won't work because RC doesn't grant mutability. I need to put this inside of a cell. Ref cell. Whoops. There we go. So then it's that dot borrow mute. And then this becomes ref MoonUnit, which lets me do stuff like this, right? Or do I have another error? I have another error somewhere else. Right, because of this, I will clone. This is wrong? No, one of these is wrong. Hold on. Oh, the I had RC in two places, right? Yeah. Cell ref cell. There. So then new has to make cell ref cell new. What a mess. It's only a mess because I'm stupid or I'm silly and I insist on not doing use. You don't think you need that? Just RC clone? No, I need to have a ref cell because I need interior mutability. I need to be able to, within that callback, actually change the MoonUnit, right? Okay, this is not quite right. Yeah, so this I need to also borrow it. So that's dot, hold on. It's not that level. It's here. Dot borrow, we can just borrow it. Then get to test suites. And that doesn't work, why? Temporary value. Owned by current function. Is it because we're opening the cell to get that test suites out? Is that the problem? What is that type? It's a cloned key. Okay, so why does it have to do with this name, this lifetime again? Don't understand any of that code. You have no idea what's going on. Yeah, I'm sorry, Deadly Doodle. They Rust. I forgot to say this the last time, but you know, like when you're learning JavaScript. Actually, let's do it this way. JavaScript learning curve, right? So you have you start here, and then here's where like it's a little bit tough at first, right? It's a little bumps in the road here, right? But you know, you start to get it, and then maybe it takes a while until you start to get to the more advanced stuff, and finally you know it, right? Expert. I need multiple cursors here. More. Okay. Beginner. I'm going to do a lame attempt at humor, okay? So there's the JavaScript learning curve. Here's the Rust learning curve. All right, ready? Beginner. They're going along, and you start to read the Rust book, and you're like, oh, okay, I get that. And then you're going along, and maybe it gets a little bit hard. And then you start to try to learn it yourself on your own, okay? And then you run into the borrow checker, and then you run into the lifetimes errors, and you're like, I have no idea what the heck I'm doing. And then someone helps you out, and you get a little bit over that, right? And then it's like, okay, cool, I think I figured out how the borrow checker works, right? And then you decide, okay, I'm going to get into async Rust, and then all of a sudden your closures do not compile it at all. It doesn't compile at all, right? Can't get the friggin' async to work. And then finally, something clicks and you get over that final curve, that final cliff, and now you are a student. And the expert is somewhere off my screen. So this is my experience. JavaScript, there are a few bumps, but you know, you can get pretty expert pretty quick. Let's just spin that for a while. But the Rust for me, you just hit these walls. And then when you get over them, you finally start to be able to write programs. I need to save this. This needs to be saved as stream notes. Rust learning cliff. So when you don't understand what's going on, you're kind of like hitting one of these cliffs, which we as Rust students hit all the time when we're learning, and we finally get over them. And so I can explain to you what like doesn't make sense and what's not, what you can't figure out what's going on. But it's really only going to get you over one of these first little bumps. That's just the way. That's the way of life for Rust. But once you get up there, hey, everything compiles. It's sweet. In the last Rust survey, it became pretty clear that medium tier tutorial are needed. Yeah, to get over those cliffs, right? There are many beginners and many pretty hard stuff, but not in the middle. Yeah, it's those cliffs in the middle that are hard. All right. I think the problem with this is that it has to do with it's inside a cell, and yeah, it's because we're borrowing here. We're creating we're getting to the inside of the cell here, and then we're returning something made from there, right? I think it's because this is again lazily evaluated. Yeah, I don't think I can do this anymore, right? Because we can't continue to borrow what's in the ref cell forever. So I think I have to. I'm forced to. I can't do a lazy evaluation of this. It has to be. What were we doing before that? It was collect into a vector of strings, and then put that into an iterator, and then we're good, right? Yeah, now we're good. So I can remove this syntax. I can remove that syntax, can't I? Wait, that's weird. Oh, because of that semicolon messed us up. I don't think I can do this anymore. When did I say that? Probably at the end of a really frustrating day when I was doing async stuff, right? Yep, today we're porting stuff to Rust from C++. This is probably I could use a comment on each of these lines, right? This would help me out and help anyone who's looking at this. Start with our data in a cell. Open up the cell to borrow the. Open up the cell to borrow the test suites inside. Get enumerate their keys, or iterate their keys. Iterate the test suite keys, the names of them. Make copies of each name. What's the right thing to say here? Push them all into a vector. Turn this into an iterator. And we're going to say up here, we have to what? We have to completely enumerate the test suites and form a new form a new iterator, a new vector iterator, since the test suites are inside a cell, meaning you can't get to them without borrowing. You can't get to them without borrowing, which we're not allowed to return. Can't return something we borrow inside. I think I'm describing it well enough there. But there's my attempt to put into English what we're doing. Start with our data, which is in a cell. Open up the cell to borrow the test suites inside. Iterate those keys. Make copies of the name. Push them into a vector. Turn that into an iterator, and that's what gets returned. We have to enumerate them completely because we're borrowing. We're opening up the cell to borrow something, and that is a temporary reference that we are not allowed to we can't allow that to escape. So we have to create something new and push stuff into that so we can get rid of that borrowed iterator and without we don't have to continue to hold this borrowed iterator to have the return value mean something. I think that's what I'm trying to say there. Anyway, this should work as long as I hooked everything up. No, I have another error somewhere. I don't think the type of this is correct. Oh, this has to be mute, right? Yeah, then we're good. Hey, look at that. We got our test suites. Nice. You caught the stream today. Hey there, the Fatexi. I have a feeling I'm saying your name completely wrong, but hello anyway. And I should also say hello to the Papada Stel Papa. And I didn't say hi to a whole bunch of people. Let me just rattle off some highs to people who've chatted recently. Hey there, Ski Dog again. You actually said it, but about the code, not about my mental state. Yeah. I'm assuming you meant mental, not metal, but yeah. Deadly Doodle, hello. You feel better about my drawing with the learning cliff? Hey there, Cat Peasant. Valcron 1000. Imagine the Haskell learning curve. That one goes backwards, and you have to have like you have to have a jetpack to make it over. And also give a hi to Crystal Coder, since you're on my list. That was 10 minutes ago. I'm sorry that it took me so long to acknowledge your presence. There it is. The Fate 12. Okay. There we go. I'll try to remember that. The Fate 12. As in the Roman numerals. Okay. So all we're doing right now is collecting the names. I think that's all this needs to actually do, right? No, we need to store the functions for some. We need to store the functions for later. Can I store them back into the cell? That would be cool. Let's try that. In fact, you know what I could do? I could push this all into here. I'm not going to. Tuabud, Lentil Stew Dragon, how are you doing? 1 year subscriber, how are you two doing today? Okay, I'm almost at 6 hours. I have to find a stopping point soon. How about let's see, how much more work do I have? We can get the test suite names. Maybe get the tests back. Where do I actually use that? I don't actually use that. Oh, maybe I do in the main .cpp. I do that here. Okay. So we get the test suite names just to count them. and then we get a total of the number of tests. Is that all we use it for? No, we also will run through them here. Okay, so they're going to be used in numerous places. Ultimately, when we run the test, how is that run? Run test, what does that do? It goes into the test. It pushes... What is this pushback? Let's get... Well, I'm in the wrong place. Run test, where does that go? Down here. It finds the test suite. It finds the test. Right, and then creates a Lua interpreter. Okay, so we have to... That's why we have to remember the file it's in, because we have to reread it again. So there's no point for me to always store that function, is there? Yeah. Where would we store it, though? I need to store it somewhere. We get it here. This test. Where do I put that? Oh, it's in the user data. I could put it in here. I could put it in the holder. That's what I can do. Hey there, Tim. How are you doing today? Let me give a shout out to Tim Bodette. He makes his own games in his own game engine in C++. They're all racing oriented or themed. And recently he's been doing some realistic racing on his battle station. It's kind of interesting and kind of chill at the same time. We all like to make fun of Tim, but in a loving way. As T.S. Jost would back me up, I'm sure you probably would. Am I changing to Rust for good? I don't know. I think for things I used to do in Python, yes. Because small one-off tools, they're easy to put in any language. And I enjoy the work so far. When I get stuff working in Rust, it usually runs the first time. There are fewer bugs. And so I just have a really nice experience with it. Changing to Rust for good, though, for other things would be kind of tough because I have a lot of work that I've done. So I'd have to convert all that extra work, which could be fun. So I just don't know yet how much of the stuff I'm going to do is in Rust. Right now, I'm still trying to do as much Rust as I can because it's new learning that I need to cement in place, or otherwise I'm just going to lose it. Like if I just learned a foreign language and I don't use it, all that newfound knowledge just goes out the other ear, right? So I'm trying to practice now to like really cement it in my brain so that I can keep it. So any opportunity I have to do work for both advancing my game and learning Rust, I'm trying to do that right now. All right, so I need to get this test and I need to save it because we're going to need it again later. After the script is evaluated. So with script, right now find tests doesn't need to do anything, right? Right. What did it used to do? Find tests. It would store the file, the path, and the line number, and that's it. It actually wouldn't do anything with the test, right? Hold on. What did this do? This actually does do something with that, right? What does it do? It's hard for me to tell because I just didn't write this very well. We know that the thing fourth down from the top of the stack is a function, but then we ended up pushing stuff, so it gets all moved around. I wish I had made comments saying what we're storing here. I think we're storing the function, the callback function. Let me look at what we do when we're actually calling run test. Yeah. It is fetching something from that registry index, isn't it? Fetching the table for the test suite, fetching the table for the name. Oh, the entry corresponding to the test is the function to call. And we were just using the keys before. Okay. I think I know what I want to do. It's within this with script context, right? Let me think about this. Yeah, I think I need to have some extra context going on into this thing. So, with Lua, makes a holder, or okay, that's what I can do. I can, when I create a new holder, I can create a new lookup table at this point, I think. Oh, you know what I could do? I can just not even store this here at all. Yeah. Yeah, what am I doing? Oh, wait. I do need a 2-level hash map. But I need another thing for test. What if I used option here? Not an option, but what if I use an enum here? It's either information about the test or it's the actual test function. Parts of Firefox are written in Rust? Wow. Okay, see you, Tim. Real short visit, that's fine. Stay as long as you'd like, or as short as you'd like. It's fine. This code needs to change because what we're doing here is just collecting information about the test. We're not going to store the tests, but it's ending up going to give stuff to Lua. Might as well store it and just not use it, right? Okay, I think that's what I'm going to do. I'm going to have the Lua function actually be stored in here. So this would be the test. I guess test function is that. Missing lifetime specifier? That needs a lifetime specifier? Oh. Okay, so how... I guess I need to make it generic. Okay, and then that permeates all this stuff. That's fine. I don't mind doing that. So that when we get down to here... Yeah, it needs to continue out. All right. Okay. That goes there, right? Okay. Okay, so then I don't need to list that, right? Perfect. So that's all the same lifetime. The lifetime of the interpreter is the same lifetime as the holder. Cool. Parallelizing the CSS styling engine in Firefox is one of the original pushes to make Rust in the first place. Really? So they tried to do it in C++ and they failed? Wow. I had no idea about that. Rust actually started as a research project at Mozilla because they needed a better language than C++ to write a web browser in. Wow. That's cool. The sync engine of Dropbox is also let's just write everything. I know the Linux kernel is about to have Rust in it. That's kind of cool too. Okay, so if we have the ability to make a test now, what is the default for a function? This must implement default, right? Is it null or something? I'm kind of curious now. What is a mlua function default? That's weird. How does... Oh, it doesn't work. There's a compiler error. Yeah. I think once I get through all these compiler errors, I'm going to run into other issues with that function. And think this is it, right? So how do I do this? This had a lifetime here, right? But I can't use the same lifetime there for some reason. The way this is defined, it had a generic in there. How do I tie those two lifetimes together? Can I? So I can't leave it off, right? Because then it says what? Lifetime parameters or bounds on method do not match the trait declaration. Lifetimes do not match method in trait. So I have to say something there. I'm not sure what to do here. Can't tie them together, probably just name them differently. Hmm. Okay. What if I use like A here? It doesn't really care what I put there. It's just I'm not sure I'll be able to do this. Let's see if I can. Sweet dot. Well, I can't use. I don't want or default actually. What I want to do is dot. Actually, that one's fine, but this one should be like or insert. I keep hitting the wrong keys. Is it insert with? Right. So this is lazy evaluate what is a default, right? Yes. So this is a function that needs to return a MoonUnit holder. No, it's not. It's a test. Right. And then I can fill these things in. Exactly what I want to do. So I should know what that is. I need to I know what I can do. I should store it in here. For now we'll just put TBD. And then in front of that I have to actually say string new, don't I? String from. I'll fill that what that really is in there in a little bit. Line number 0. So here, this is the tricky part, right? I want to be able to store the test there. I don't know if I can do that though. Can't infer an appropriate lifetime for lifetime parameter Lua due to conflicting requirements. Expected A found underscore expected Lua found underscore. First lifetime can, yeah. So I'm trying, how do I get A and Lua to be together? That's the trick. Yeah, I would like to say, oops, Lua there, because then I want to be able to say that's the same lifetime. Because I want to take that test, which is that lifetime, and store it in one of these that has that lifetime. Can you do that? Like here? So call this A again. Where A Lua? Can I do that? Nope. Can't do that. Impl stricter requirements than trait. Impl extra requirement A subset of Lua. I can't do that. I don't know, maybe it can't be done. How would I do it a different way? Let me go through and call, well, no, I'll just leave it at this line. I'm stuck. It's probably a good time for me to stop since I passed 6 hours. So I'm going to continue, I'll try to figure this out and continue this tomorrow. What I really want to do is to be able to save all the information about the test in here so that we can both report where these tests are and be able to run them as long as we still have this context. I just need to figure out how to associate these two together. Yeah, the thing is, if I don't declare anything at all, it throws a fit. It will tell me that it needs a lifetime there, and when I say that, it'll say they don't match the declaration. So then I have to say something. So when I say something, then it has a problem with that because the lifetimes don't match. So I just have to figure out what the syntax is. Use underscore instead of Lua in user data methods. So like here. Do not match trait declaration. Yeah, I don't know. I'll figure it out later. I need to go. I need to eat. It's like past 3 a.m. or 3 p.m. I can't even say a.m. versus p.m. Not in the beginning. Not in the beginning. Not in the beginning. I'm not sure what you mean then. You mean here? An A here or something? Yeah. I'll toy with this. I'll try to figure it out. I need to call it here because I need to go eat. So what I'm gonna do? That's weird. I've got a network error reading my own stream. Pretty sure my stream is still going. Anyway, I'm going to go raid somebody so I can go eat. And I'll continue this work tomorrow. So let me go find somebody. Okay, it's been a while, and so I think it's an okay time to raid this fine streamer who is also doing Rust, but with WebAssembly and you. I hope you enjoy watching him write with you. It's Mr. Sir, CM Griffin. He is the maker of Stream Parrot, which is the chat overlay above my head, so when you see it on his stream too, it's because he wrote it. Good night, Nui, and goodbye to all of you guys. Kamandi, Papadas Del Papa, the Fate 12, and everybody else. Hope you enjoy Chris's stream. Just a heads up, it's a mature audience stream, so you might hear some bad words. Just give you fair warning. Yes, good night for some of us, good morning for others. Hope you all have an awesome rest of your day. And hopefully see you tomorrow. So take care, enjoy Chris's stream, and until next time, bye.